There are moments on mountains when silence feels like a presence. Camp Muir sits at 10,188 feet on the southern flank of Mount Rainier, a cluster of stone shelters clinging to a snowfield between the Cowlitz and Muir glaciers. It serves as the primary staging point for summit attempts via the Disappointment Cleaver route. The camp is named after John Muir, who climbed Rainier in 1888 and spent a night near this elevation, though not at this exact location. The Park Service built the first stone hut here in 1921. By the early 1980s, the camp consisted of a public shelter, a guide service hut, and a ranger's station used during climbing season. Mount Rainier is a stratovolcano, one of the most glaciated peaks in the contiguous United States. Its weather is notoriously unpredictable. Climbers often report sensory disorientation at altitude, the thin air, the glare of ice, the wind that never quite stops. But Camp Muir is below the technical climbing zone. Most parties spend a night there to acclimatize before continuing upward at dawn. It is exposed but not extreme. Cell phones did not exist in 1983. Radio contact with Paradise, the nearest ranger station, was sporadic but functional. The camp has seen its share of tragedy: avalanches, falls, altitude sickness. In 1946, a military transport plane crashed into the South Tahoma Glacier, killing 32 Marines. In 1981, 11 climbers died in an icefall near Ingraham Glacier, the worst accident in the mountain's recorded history. But what happened in July of 1983 was not a disaster in the traditional sense. There were no injuries. No one died. And yet the incident was classified in Park Service records as atmospheric anomaly, pending review, a designation that has never been updated. On the night of July 9, 1983, 6 climbers were camped at Muir. Their names were registered at the Paradise Climbing Desk. David Kowalski, a 34-year-old engineer from Portland. His climbing partner James Okoro, 31, originally from Lagos, but living in Seattle. 2 women from Spokane, Lisa Vanucci, 29, and Rebecca Stroud, 26, both school teachers on summer break. And a married couple from Vancouver, British Columbia, Michael and Annika Bergstrom, both in their early 40s. All 6 were experienced mountaineers. None had altitude sickness. The weather was clear, though wind was expected to pick up after midnight. They had arrived at Camp Muir around 3 p.m., secured sleeping spots in the public shelter, melted snow for water, and ate freeze-dried meals. By 9 p.m., most had retreated into their sleeping bags. The plan was to wake at 2 a.m. and begin the summit push. According to later interviews, conditions were normal, cold but manageable, wind gusting at 15 to 20 miles per hour, visibility excellent under a waning gibbous moon. At 2:47 a.m., the wind stopped. David Kowalski, who was awake adjusting his crampons outside the shelter, noticed it first. He later described the cessation of sound as surgical. One moment, the wind was loud enough that he had to shout to be heard. The next, nothing. Not the absence of wind, the absence of sound itself. His crampons made no noise as they scraped the ice. His breath produced no vapor cloud, though he could still feel air moving through his lungs. He turned toward the shelter and called out. He heard nothing, not even the vibration of his own voice in his skull. Inside the shelter, the other 5 climbers woke simultaneously. None could say why. Rebecca Stroud later told a park ranger that she opened her eyes and knew immediately that something was wrong, though she could not articulate what. Michael Bergstrom tried to unzip his sleeping bag and found that the zipper moved soundlessly. He stood. His boots made no contact noise against the wooden floor. He looked at his wife. Her mouth was moving, but there was no sound. All 6 climbers converged outside the shelter. The moon was still visible. The stars were clear, but the wind had stopped, and with it, every other sound. Lisa Vanucci held up her wrist and pointed to her watch. The second hand was frozen. James Okoro checked his own watch, also stopped. Every timepiece among the group showed the same time, 2:47. They stood in the snow for what felt like several minutes, though none could say for certain how long. No one panicked. Panic, David Kowalski later explained, requires sound, the sound of breathing, of heartbeat, of movement. Without those auditory cues, the body does not recognize crisis. They stood and waited. Some looked at the summit. Others looked down toward paradise, where distant lights should have been visible. The lights were there, but they seemed static, as if painted onto glass. And then, without warning, sound returned. The wind resumed at the exact volume it had been before. Conversations half finished in the climbers' minds became audible again. Rebecca Stroud was saying, "Even hear myself think." Michael Bergstrom was mid-sentence. "The hell is happening?" Every watch resumed ticking. All showed 2:51 a.m. 4 minutes had passed. The group spent the next hour discussing what to do. The summit attempt was abandoned by unanimous agreement. They descended to paradise at first light. David Kowalski reported the incident to the ranger on duty, a woman named Sandra Hallinan, who had been stationed at Paradise for 3 seasons. She took notes, asked clarifying questions, and radioed the incident to the Park Service Regional Office in Longmire. Sandra Hallinan later said the climbers seemed shaken but coherent. They weren't hysterical, she recalled in a 1997 interview with a mountaineering journal. They were trying to make sense of it. They kept asking me if there had been reports of auroras, or military aircraft, or anything unusual in the airspace. I checked with the FAA. Nothing. James Okoro described the silence as total, not quiet total. "I've been in anechoic chambers for work," he said. "This was different. In a chamber, you still hear your body, your heartbeat, your joints. This was like being severed from the world." Lisa Vanucci, in a follow-up letter to the Park Service, wrote, "I've replayed that night in my mind hundreds of times. I keep coming back to the watches. 6 watches. All stopped at the same second. All restarted at the same second. I'm not a religious person, but I don't know how to explain that." Annika Bergstrom refused to speak about the incident after 1984. Her husband, Michael, gave one interview to a Seattle newspaper in 1986, in which he said, "We didn't imagine it. Whatever happened, it was real. But I've stopped trying to explain it. No one believes us anyway." The Park Service opened an investigation on July 11, 1983. A 3-person team was dispatched to Camp Muir to inspect the site. They found no physical evidence of any anomaly. The stone shelters were intact. No equipment malfunctions were reported by other climbing parties in the days following. Weather records from Paradise showed clear skies and moderate wind speeds throughout the night of July 9th. Seismic monitors recorded no unusual activity. Electromagnetic sensors, which had been installed on Rainier in 1979 to study volcanic precursors, showed no spikes or irregularities. The Park Service contacted the National Weather Service, the USGS, and the University of Washington Department of Atmospheric Sciences. None could offer an explanation. A meteorologist named Dr. Rajesh Patel reviewed the data and noted that localized wind cessation was theoretically possible under certain pressure conditions, but could not account for the simultaneous stoppage of all sound, including human voice and mechanical noise. He also could not explain the watches. A geophysicist, Dr. Ellen Voss, suggested that a brief geomagnetic disturbance could affect electronic devices, but the climbers' watches in 1983 were mechanical, not quartz. She reviewed the seismic data personally and found nothing anomalous. In her report filed with the USGS in August 1983, she wrote, "The described event does not align with any known geophysical or atmospheric phenomenon. Further investigation is recommended, though I am uncertain what form that investigation should take." The Park Service did not pursue further investigation. The case was transferred to a filing category labeled Atmospheric Anomaly, Unresolved. a designation used for fewer than a dozen incidents in Park Service history. David Kowalski requested copies of all related documents in 1985 under the Freedom of Information Act. He received 23 pages, most of which were incident reports and weather data he had already seen. 3 pages were redacted in full. The reason given was internal review pending. In 1989, a climbing guide named Thomas Lund reported a brief period of disorienting quiet at Camp Muir during a night climb. The incident lasted less than 30 seconds. His clients did not notice anything unusual. Lund mentioned it in passing to a ranger and was told that strange acoustics sometimes occurred at high altitude due to wind patterns. No formal report was filed. In 2004, a solo climber named Yuki Tanaka emailed the Mount Rainier National Park Superintendent's office, describing an experience at Camp Muir that matched the 1983 account almost exactly. She reported that all sounds stopped for several minutes around 3 a.m. Her watch did not stop, but she noted that her phone turned off to conserve battery powered on by itself when sound returned. The Park Service responded with a form letter, thanking her for her message and encouraging her to report safety concerns through official channels. Rebecca Stroud, one of the original 6 climbers, became a Park Service volunteer in her 50s. She returned to Camp Muir 7 times between 2010 and 2015. She never experienced the silence again. In an email to a fellow volunteer in 2014, she wrote, "I go back because I want to understand it. Not what caused it. I've accepted. I'll never know that. But what it meant. Why we were there. Why that night." David Kowalski died in 2018. In his belongings, his daughter found a notebook filled with calculations, altitude, barometric pressure, lunar phase, magnetic declination. He had tried to find a pattern. There was none. Camp Muir remains one of the most popular high camps on Mount Rainier. Thousands of climbers pass through each season. The stone shelters are unchanged. The wind still gusts across the snowfield. Watches keep time. And somewhere in a filing cabinet in a Park Service regional office, a folder marked Atmospheric Anomaly, July 1983, sits untouched, waiting for a review that will never come. Sometimes a photograph remembers what the eye chooses to forget. The Cowlitz Divide is a high ridge on the eastern shoulder of Mount Rainier, accessible via a steep trail that branches from the Wonderland Trail near Panhandle Gap. At elevations between 6,000 and 7,000 feet, the divide offers sweeping views of the Cowlitz Glacier to the north and Ohanapekos Park to the southeast. The terrain is alpine tundra, sparse vegetation, wind-scoured rock, and seasonal snowfields that persist into late summer. The trail itself is narrow and exposed, requiring careful footing. In poor weather, visibility drops to near zero within minutes. Mount Rainier National Park was established in 1899, making it one of the oldest national parks in the United States. The Cowlitz Divide Trail, however, was not officially maintained until the 1960s. Before that, it was used primarily by mountaineers as an approach route to the eastern glaciers. Local indigenous groups, including the Cowlitz and Yakama peoples, considered the upper slopes of Rainier to be sacred and avoided prolonged stays at high elevation. There are no recorded place names for the Cowlitz Divide in indigenous languages, though oral histories reference the ridge where the wind speaks backward, a phrase whose meaning has been lost. By the mid-1970s, the Cowlitz Divide had become a moderately popular destination for experienced day hikers. The Park Service installed trail markers in 1974. A backcountry campsite was designated near Panhandle Gap in 1976. Still, the area remained less trafficked than trails on the mountain's western and southern flanks. Weather conditions were unpredictable. Summer storms could arrive with little warning, trapping hikers above treeline for hours. In August of 1977, a family from Tacoma Philip and Margaret Vukovich, and their teenage son, Daniel, hiked the Cowlitz Divide on a clear afternoon. They stopped near the ridgeline to rest and take photographs. Philip used a Kodak Instamatic camera, standard consumer equipment for the time. He took 6 photographs, 3 of the surrounding peaks, 2 of his wife and son, and 1 wide-angle shot of the snowfield to the north. The family returned home, developed the film at a local drugstore, and placed the prints in an album. 3 months later, in November, Margaret Vukovich was showing the photographs to a neighbor when she noticed something unusual in the wide-angle shot. In the distant snowfield, barely visible against the white expanse, stood a dark figure. It appeared to be a person, upright and motionless, facing the camera. Margaret did not recall seeing anyone else on the trail that day. She asked her husband and son. Neither remembered another hiker. The figure was too far away to discern details, no clothing colors, no facial features. But the posture was unmistakably human. Philip Vukovich assumed it was simply someone they had not noticed. The snowfield was several hundred yards from where they had been standing. It was possible, he reasoned, for a distant hiker to escape attention, especially if they were standing still. Margaret was less certain. She remembered scanning the landscape carefully before Philip took the photograph. The snowfield had been empty. The family did not report the photograph to anyone. It became a minor curiosity, occasionally mentioned at dinner parties. But in the summer of 1978, during a visit to the Park Service Visitor Center at sunrise, Margaret mentioned the photograph to a ranger named Thomas Okafor. She described it casually as an oddity rather than a concern. Okafor, who had worked on Rainier for 6 years, asked if she still had the photograph. She did. He requested that she mail a copy to the ranger station at White River. 2 weeks later, Okafor called the Vukovich home. He asked if they would be willing to come to the ranger station to discuss the photograph in person. Margaret agreed, puzzled by the formality. When the family arrived, Okafor led them into a back office where another ranger, a woman named Sandra Ilunga, was waiting. On the desk were 4 other photographs, spread out in a row. Each photograph showed the Cowlitz Divide from a slightly different angle. Each had been taken by a different person, on different days, during the summers of 1977 and 1978. And in each photograph, in the distant snowfield, stood the same dark figure. The photographers were unrelated to one another. 2 were couples from Seattle and Portland. One was a solo hiker from Bellingham named Yuki Matsuda, a software engineer who had hiked the divide in late July of 1977. Another was a group of 3 college students from Olympia, Gabriela Ruiz, Marcus de Leon, and Priya Lagari, who had camped near Panhandle Gap in early August of 1978. None of the photographers recalled seeing another person in the snowfield. Several insisted the field had been empty when they took the pictures. Thomas Okafor explained that the Park Service had become aware of the photographs through separate incidents. Yuki Matsuda had written a letter to the superintendent's office in 1978, inquiring whether the Park Service kept records of search and rescue operations in the Cowlitz Divide area. She had found the figure in her photograph months after the hike and wondered if it might be connected to a missing person case. The superintendent's office forwarded the letter to Okafor, who had recently received a similar inquiry from the couple in Portland. Sandra Ilunga, who had been stationed at White River since 1976, recalled a conversation with an elderly hiker in the summer of 1977. The man had shown her a photograph taken near the Cowlitz Divide and asked if the Park Service employed spotters or observers in remote areas. He had noticed a figure in the snowfield and assumed it was a ranger. Ilunga had told him that the Park Service did not station personnel in that location. The man thanked her and left. She did not record his name. By the end of 1979, the Park Service had collected 12 photographs. All depicted the same section of the Cowlitz Divide. All were taken between late June and early September, during the brief window when the trail was accessible. All showed the figure in the snowfield. The photographers ranged in age from 19 to 62. They used different cameras: Instamatic, Polaroid, 35mm SLR. The figure appeared in roughly the same position in every image, though the angle and distance varied depending on where the photographer had been standing. Margaret Vukovic later described the figure as patient. She could not explain why she used that word. It wasn't doing anything, she said in an interview in 1994. It was just standing there. But when you look at it, you get the sense that it's been there a long time, that it's waiting. Yuki Matsuda was more analytical. I'm trained to troubleshoot problems, she said. I went through every rational explanation. Trick of the light, shadow cast by a rock formation, optical illusion caused by snow glare. None of them fit. The figure is three-dimensional. It casts a shadow, and it's in the same place in 12 different photographs taken by 12 different people who didn't know each other. Priya Laghari, one of the college students, described feeling unsettled when she first noticed the figure. We were sitting around a campfire, looking through the photos we'd taken, she said. Gabriella held up this one shot of the divide and said, "Who's that?" We all leaned in. None of us had seen anyone out there. The snowfield had been completely empty. I'm sure of it. Marcus De Leon, Laghari's friend, was less certain. Memory is unreliable, he said. Maybe there was someone there and we just didn't notice. But the thing that bothers me is how far away it is. That snowfield is at least a quarter-mile from where we were standing. If someone was standing there, they would have had to hike across rough terrain to get there. And for what? To stand in the middle of a snowfield and stare at hikers? In October of 1979, the Park Service contacted the University of Washington Department of Geography to request assistance analyzing the photographs. A graduate student named Dr. Elena Vargova, specializing in photographic interpretation and cartography, was assigned to the project. She examined all 12 images using a stereoscope and compared them to topographic maps of the area. Her findings, submitted in a preliminary report in December 1979, noted several inconsistencies. The figure's position relative to surrounding landmarks, rocks, snow patches, ridge lines, did not change significantly across the photographs, despite the fact that the photographers had been standing at different elevations and angles. In a normal landscape, parallax would cause distant objects to shift position relative to foreground and background features. The figure did not shift. It remained fixed, as if anchored to a specific coordinate. Vargova also noted that the figure's size was difficult to determine. Based on distance estimates, it should have appeared much smaller in the photographs. Yet it was clearly visible, even in images taken from farther away. She wrote, "The figure's apparent size suggests it is either much larger than a human or much closer to the camera than the surrounding terrain indicates. Neither explanation is consistent with the photographic evidence." The Park Service requested additional analysis, but Vargova's work was interrupted in early 1980, when the university revoked her access to the photographs. No official reason was given. In a personal letter to Thomas Okafor, Vargova wrote, "I was told the project had been reclassified and that my involvement was no longer required. I was not informed of the new classification level, nor was I given an opportunity to complete my analysis. This is highly irregular." In March of 1980, the Park Service sent letters to all 12 photographers, requesting the original photographs and negatives. The letters stated that the images were needed for ongoing geographic documentation and assured the families that the materials would be returned within 6 months. Most complied. The Vukovic family sent their original print and negative. Yuki Matsuda sent her negatives along with several additional prints she had made. The college students from Olympia sent their originals. None of the photographs were returned. Follow-up inquiries were met with form letters stating that the materials were in storage pending review. In 1982, Philip Vukovic filed a Freedom of Information Act request for the return of his family's photograph. He received a response in 1983 stating that the materials could not be located in Park Service archives. The letter suggested that they may have been misfiled or lost during an office relocation. Thomas Okafor retired from the Park Service in 1987. In a 1996 interview with a regional history journal, he was asked about the Cowlitz Divide photographs. He said, "I was told to drop it." Not in those words, but that was the message. There was no official directive, just a quiet reassignment. I was moved to a different district. The photographs disappeared. I have no idea where they are now. Sandra Ilunga left the Park Service in 1989. She declined multiple requests for interviews about the incident. The Cowlitz Divide Trail remains open. Thousands of hikers pass through each year. Many take photographs. In online hiking forums, occasional posts appear from people who claim to have seen unusual figures in their Rainier photos, though none have produced images comparable to the originals from the late 1970s. The Park Service does not acknowledge the incident in any official capacity. Margaret Vukovic kept a copy of the photograph, a duplicate print she had made before sending the original to the Park Service. She framed it and hung it in her study. Visitors who saw it often asked about the figure. She would tell them the story, then add, "I've thought about it for 40 years. I still don't know if we saw something that was there or if we failed to see something that wasn't." Some names are written by hands that should not exist. The Paradise Inn sits at 5,400 feet on the southern slope of Mount Rainier, surrounded by subalpine meadows that bloom briefly each summer before the snow returns. The inn was built in 1916 using salvaged timber from a forest fire, its massive exposed beams giving the lobby a cathedral-like quality. It was designed to accommodate the growing number of tourists visiting the newly accessible national park. By the early 1950s, the inn had become a destination in itself, rustic but elegant, hosting everyone from casual sightseers to serious mountaineers preparing for summit attempts. The inn operated seasonally, typically opening in late May and closing in early October. During the off-season, heavy snow made the access road impassable. Maintenance and renovations were scheduled during these closure periods. The building's age and the harsh alpine environment required constant upkeep. In 1952, the Paradise Inn underwent significant structural repairs to its foundation and roof. The work began in late April. The inn did not open to guests that summer. Guest registries were leather-bound ledgers kept at the front desk, where arriving visitors would sign their names, hometowns, and dates of stay. These books served both administrative and historical purposes, a record of who had visited, when, and from where. The registries were stored in the inn's office after each season. By 1952, there were dozens of these ledgers, dating back to the inn's opening. On October 8, 1952, when the renovation crew completed their work and prepared to close the building for winter, the foreman, a man named Walter Novak, noticed something unusual. A guest registry that should have been empty set aside for the upcoming 1953 season had been filled out, not extensively, but enough to catch his attention. An entire page contained signatures, all dated June 14, 1952. Novak assumed one of his workers had been careless, perhaps using the ledger as scrap paper, but when he examined the entries more closely, he realized they followed the proper format. Each line contained a full name, a city or state, and the date. The handwriting varied from entry to entry. Some signatures were neat and careful, others hurried or illegible. There were 43 signatures in total. Novak showed the registry to his assistant, Daniel Kowalski, who had worked at Paradise Inn for 6 seasons. Kowalski confirmed that the inn had been closed on June 14th. No guests had been admitted. The only people with access to the building were renovation workers, and Kowalski knew all of them by name. None of the signatures matched their names. More puzzling, several of the listed hometowns were specific and distant. Memphis, Tennessee, Halifax, Nova Scotia, Duluth, Minnesota. Why would someone fabricate such detailed entries? The registry was brought to the attention of the Park Service the following week. A supervisor named Margaret Desjardins reviewed the ledger and cross-referenced the signatures with records from the 1952 season. She found no corresponding reservations or inquiries. The inn had been publicly listed as closed for renovations since March. There should have been no confusion. Desjardins might have dismissed the incident as a prank, if not for a detail that emerged during her review. One of the names in the registry, Robert Callahan, Portland, Oregon, matched the name of a passenger on a charter flight that had disappeared over the Cascade Range on May 23, 1952. The flight, a small twin-engine Beechcraft, had been carrying 9 passengers and a pilot from Seattle to Redmond, Oregon. It vanished in clear weather. No wreckage was ever found. The discovery prompted a more thorough investigation. Desjardins obtained the passenger manifest from the Civil Aeronautics Administration. She compared it to the names in the Paradise Inn registry. 2 more matches appeared: Helen Morgenstern from Spokane, Washington, and James Braddock from Eugene, Oregon. Both had been on the missing flight. The Park Service contacted the families of the 3 passengers. Robert Callahan's widow, Dorothy, confirmed that her husband's handwriting in the registry resembled his usual signature, though she could not be certain without seeing the original. Helen Morgenstern's brother, a postal clerk named Thomas Morgenstern, examined a photocopy of the registry and said the signature looked close but not exact. James Braddock's sister, Ruth Vukovich, refused to comment, stating only that her brother had never visited Mount Rainier and would have had no reason to sign a registry there. The remaining 40 signatures in the registry did not match known missing persons from that period. Some of the names were common: John Miller, Mary Sullivan, David Martinez, making verification difficult. Others were unusual enough that investigators assumed they could be traced, but inquiries to city directories and local newspapers turned up no clear matches. A name like Isidro Tamayo, Santa Fe, should have been easy to confirm, but no one by that name could be located in New Mexico during the early 1950s. A handwriting analyst named Dr. Yael Rothstein, working for the Washington State Patrol, was asked to examine the registry in December 1952. Her analysis took 3 weeks. She concluded that the 43 signatures had been written by at least 38 different individuals. The variation in pressure, slant, letter formation, and pen type made it highly unlikely that one person had forged all the entries. She noted that several signatures showed signs of hesitation, the places where the pen had paused mid-stroke, as if the writer were uncertain or distracted. Others were fluid and confident. Rothstein could not determine when the entries were made. Ink analysis suggested a standard blue fountain pen ink common in the early 1950s, but the ink had aged consistently with the paper, making it impossible to say whether the signatures were written in June or sometime later. She noted one oddity: the ink on several signatures appeared slightly smudged, as though the writer's hand had been damp. Other signatures on the same page showed no smudging. Interviews with the renovation crew yielded little. Walter Novak and his team of 7 workers all stated that they had not seen anyone enter the inn who did not belong there. The building was locked each evening. Novak held the only key. The crew worked 6 days a week, arriving at 7 a.m. and leaving by 4 p.m. On Sundays, the building was unoccupied. June 14, 1952, had been a Saturday. The crew had been on site that day, working primarily on the second-floor guest rooms and the roof. One worker, a carpenter named Tomas Ibarra, recalled hearing footsteps in the lobby around noon. He had been alone on the second floor at the time, sanding a windowsill. The sound lasted only a few seconds, boot heels on wooden floorboards, and then stopped. Ibarra assumed it was Novak or one of the other workers. When he went downstairs a few minutes later to retrieve a tool, the lobby was empty. He thought nothing of it. Another worker, a young man named Elliot Byrne, mentioned that the front door had been found unlocked on the morning of June 15th. Novak had been irritated, suspecting someone had forgotten to secure it the previous evening. Each member of the crew denied responsibility. Novak checked the interior. Nothing appeared disturbed. He locked the door himself and warned the crew to be more careful. The Park Service expanded its investigation to include other missing persons cases from the spring and summer of 1952. The Cascade Range, a vast and heavily forested mountain corridor, had seen numerous disappearances over the years. Hikers, hunters, small aircraft. Search efforts were often hampered by terrain and weather. Many cases remained unsolved. A researcher named Dr. Amara Singh, working with the University of Washington's History Department in the 1980s, attempted to trace the origins of the Paradise Inn registry signatures. She focused on the 3 names that matched the missing flight passengers. Through FAA records, she confirmed that the Beechcraft had filed a flight plan that would have taken it south of Mount Rainier, not directly over it. Weather reports from May 23rd showed clear skies and light winds, ideal flying conditions. The plane's last radio contact had been routine. There was no distress signal. Singh interviewed surviving family members and obtained samples of the passengers' handwriting from personal letters and documents. She compared these to the registry signatures. In her 1987 paper, published in a regional historical journal, she wrote, "The similarities are suggestive, but not conclusive. Handwriting can change under duress or in unfamiliar circumstances. What remains unexplained is how 3 names from a flight that disappeared 3 weeks prior to June 14th appear in a registry for an inn that was closed and unoccupied. Attempts to locate the original registry in the 1990s were unsuccessful. The Park Service stated that it had been transferred to the National Archives in 1964 as part of a routine records consolidation. The archives confirmed receiving materials from Mount Rainier National Park that year, but could not locate the specific registry in question. A search request filed in 1998 produced no results. The ledger was listed as missing or misfiled. Margaret Desjardins, the Park Service supervisor who first investigated the registry, retired in 1973. In a 1991 interview with a local newspaper, she was asked if she believed the signatures were genuine. She said, "I don't know what genuine means in this context. The signatures were real, written by real hands, using real ink. But who wrote them and why? I can't say. I've thought about it for 40 years. I don't have an answer." Walter Novak, the renovation foreman, left Mount Rainier in 1954 to work on construction projects in Oregon. Before his death in 1979, he gave a brief statement to a writer researching unexplained events in the Pacific Northwest. He said, "I lock that building every night. I'm certain of it. But I can't explain the registry. I wish I could." The Paradise Inn continues to operate each summer. Modern guests sign in using digital systems. The old leather-bound registries are stored in the park's archive facility in Longmire, though public access is restricted. Requests to view registries from the 1950s are typically denied, with staff citing preservation concerns. In 2006, a hiker named Priya Lagari claimed to have seen a photocopy of the 1952 registry page in a ranger station office. She photographed it with her phone before being asked to leave. The image, posted briefly online, showed a page of signatures dated June 14th. The post was removed within 48 hours. Lagari later stated that she could not locate the original photo on her device. She described it as clear enough to read, but the names meant nothing to me. The Paradise Inn registry remains one of the least discussed anomalies in Mount Rainier's history. No plaques mark the event, no official documentation acknowledges it, and yet the ledger existed. 43 people signed their names on a day when no one should have been there, in a building that was locked and empty. 3 of those names belonged to passengers on a plane that never landed. A reflection should only show what is already there. Reflection. Lake sits along the Stevens Canyon Road in Mount Rainier National Park, approximately 18 miles from the Paradise Visitor Center. The site consists of a series of shallow alpine tarns fed by snowmelt, positioned to provide a mirror image of Mount Rainier's southern face. On calm days, the mountain's reflection appears nearly perfect in the still water 14,410 feet of volcanic mass, duplicated in miniature. Photographers have visited the location since the park's establishment in 1899, drawn by the symmetry and the way light moves across both the physical peak and its reflected double. The lakes are small, none deeper than 8 feet. They freeze solid in winter and thaw by late June. The surrounding terrain is subalpine, forest mountain hemlock, and Alaska yellow cedar, with patches of exposed granite. The area is accessible by road during summer and early fall, making it one of the more visited photography locations in the park. By mid-October, the road closes due to snow, and the lakes remain inaccessible until the following June. Weather patterns at Reflection Lakes can shift rapidly. The mountain generates its own microclimate, pulling moisture from the Pacific and creating localized storms that appear with little warning. Fog banks roll through the basin. Rain turns to sleet at higher elevations. But the lakes themselves, positioned in a relatively sheltered depression, often remain calm even when wind tears across the ridges above. This stillness is what makes the reflections possible. On September 7th, 1991, a family from Olympia, Marcus and Nadia Sorensen, their 11-year-old daughter Ingrid, and Nadia's brother, Henrik Johansson, visited Reflection Lakes in the late afternoon. The day was unusually clear. No clouds obscured the summit. The Sorensens had visited the location twice before and considered it one of their favorite spots in the park. They arrived around 4:15 p.m., parked in the small lot off Stevens Canyon Road, and walked the short trail to the lakeshore. Marcus carried a Nikon FM2, a 35mm film camera he had owned since the early 1980s. He was an amateur photographer, careful about composition and light. The family spent nearly an hour at the lake, taking pictures and watching the reflection shift as the sun lowered. Marcus shot an entire roll of film, 36 exposures. Most were of the mountain and its reflection. A few were of Ingrid and Henrik standing near the water's edge. The family returned home that evening. Marcus dropped the film at a 1-hour photo lab in Olympia the following Monday. When he picked up the prints on Tuesday, he noticed something wrong with several of the images. In 3 consecutive photographs, frames 22, 23, and 24, the reflection in the lake did not match the mountain above it. In the photographs, Mount Rainier stood clear and bright against a cloudless sky, but in the water, the reflection showed the mountain obscured by dark storm clouds. Lightning was visible in one frame, a jagged white line cutting across the reflected sky. The water itself appeared undisturbed, smooth and glassy, suggesting no wind or disturbance. But the image in the water was wrong. Marcus assumed the lab had made an error during development. He returned to the shop and asked to see the negatives. The technician, a man named Robert Delgado, examined them under magnification. The negatives showed the same anomaly. The storm clouds and lightning were present in the reflected image, not added during printing. Delgado, who had worked in photo development for 12 years, told Marcus he had never seen anything like it. Nadia Sorensen later described her reaction as confusion, followed by disbelief. "At first, I thought it was some kind of double exposure," she said in a 1998 interview. But Marcus doesn't make mistakes like that. And it wasn't just one photo, it was 3 in a row. The mountain was clear in all of them, but the reflection showed a storm. Henrik Johansson, a high school physics teacher, examined the photographs and the negatives closely. He noted that the lighting in the images was consistent. The sun angle, the shadows on the trees, the quality of light on the mountain all matched a late afternoon in early September. There was no indication that the photos had been taken at different times or under different conditions. The only thing that didn't match, he said, was the reflection. Marcus contacted the Park Service the following week. He spoke with a ranger named Lillian Okafor, who had been stationed at Mount Rainier since 1986. Okafor asked Marcus to bring the photographs to the Longmire headquarters. When she saw them, she was silent for several seconds. Then she asked Marcus to wait while she retrieved something from a filing cabinet. Okafor returned with 2 other photographs, both taken at Reflection Lakes. Both showed the same inversion, a clear sky above, storm clouds in the water below. One had been submitted by a photographer from Portland named Yuki Tanaka on September 9, 1991. The other had been sent in by a tourist from Alberta, David Kowalski, on September 10th. Both photographers had been at Reflection Lakes during the same hour as the Sorensens, between 4 and 5 p.m. on September 7th. Yuki Tanaka had noticed the anomaly immediately when she reviewed her slides. She used a Canon AE1 and shot exclusively on Kodachrome film. Her slides showed the inversion in 4 separate frames. She had written to the Park Service, asking if there was a meteorological explanation, perhaps an atmospheric phenomenon she was unaware of. Her letter was dated September 10, 1991. David Kowalski, a retired electrician, had been traveling through the park with his wife Elena. He had taken 2 photographs with a disposable camera. When the prints came back, he noticed the storm clouds in the reflection, but assumed it was a processing error. His wife convinced him to contact the Park Service after reading a newspaper article about unusual weather patterns in the Cascades. His letter arrived on September 14th. A 4th photographer, a man named Jamal Rousseau from Tacoma, came forward in late September after hearing about the incident through a local camera club. Rousseau had been at Reflection Lakes on September 7th, between 4:30 and 5 p.m. He shot medium format film using a Hasselblad. His images showed the same inversion clear sky, storm in the reflection. Rousseau was an experienced photographer and immediately recognized the anomaly as something beyond equipment malfunction. He had kept the photographs but had not reported them, unsure who to contact or whether anyone would believe him. All 4 photographers were certain of the weather conditions that day. Clear skies, no storms, no lightning. The Park Service verified this through meteorological records. The National Weather Service station at Paradise logged clear conditions throughout September 7th. A ranger who had been stationed at the Box Canyon area, less than 5 miles from Reflection Lakes, confirmed that the weather had been stable all afternoon. No storms were reported within 200 miles of Mount Rainier that day. Lillian Okafor contacted the University of Washington Department of Atmospheric Sciences. A meteorologist named Dr. Amara Singh reviewed the photographs and weather data. Her initial response, delivered in a phone call to Okafor on September 23rd, was that the images represented an optical phenomenon I cannot currently explain. She requested copies of all the photographs and negatives for further analysis. Singh's analysis took 6 weeks. Her report, completed in early November 1991, examined several possibilities. Atmospheric inversion, a meteorological condition where temperature layers trap light in unusual ways, was considered but ruled out. Such inversions affect both the direct view and the reflection equally. Light refraction from distant storms was also considered, but the nearest storm system on September 7th had been over the Pacific Ocean, more than 100 miles away, and would not have been visible from Reflection Lakes. Singh noted something unusual about the storm depicted in the reflections. The cloud formations were consistent across all 4 photographers' images, suggesting they were photographing the same phenomenon rather than random processing artifacts. The lightning, visible in 2 of the sets of photographs, appeared in roughly the same position relative to the mountain. This suggested the reflected storm was not random, but represented a specific weather event. But there had been no storm. Singh consulted with Dr. Helena Vargas, a physicist specializing in light and optical systems. Vargas examined the photographs and concluded that the reflections followed the normal laws of optics. Angle of incidence equaled angle of reflection. The images were not distorted beyond what would be expected from minor water surface irregularities. These are real reflections, Vargas wrote in her notes. They're reflecting something. The question is what? The Park Service submitted a request to the National Oceanic and Atmospheric Administration for satellite imagery from September 7, 1991. NOAA provided infrared and visible light images taken by weather satellites throughout the day. None showed storm activity over Mount Rainier or the surrounding region. The satellite data confirmed what ground observers already knew: the weather had been clear. In December 1991, the Park Service sent letters to all 4 photographers requesting that they submit their original photographs and negatives for further meteorological study. Marcus Sorensen, Yuki Tanaka, and Jamal Rousseau complied. David Kowalski declined, citing concerns about losing his only copies. The Park Service assured him the materials would be returned within 6 months. They were not. Follow-up inquiries in 1992 were met with bureaucratic delays. Marcus Sorensen was told the photographs were under review by external consultants. Yuki Tanaka received a letter stating the materials had been transferred to a NOAA facility in Boulder, Colorado, for atmospheric analysis. Jamal Rousseau's inquiries went unanswered. In 1994, Marcus Sorensen filed a Freedom of Information Act request for the return of his photographs. He received a response in 1995 stating that the materials could not be located. The letter suggested they may have been lost during an interagency transfer. Lillian Okafor, the ranger who first collected the photographs, left the Park Service in 1993. In a 2002 interview with a regional magazine, she said, "I don't know what happened to those photos. I logged them into evidence. I sent them to the people I was supposed to send them to. After that, they were out of my hands. I wish I'd made copies." Dr. Amara Singh, the meteorologist who analyzed the images, retired from the University of Washington in 2006. Before her retirement, she was asked by a graduate student about the Reflection Lakes photographs. Singh said, "I wrote a report. I submitted it. I was told the findings were inconclusive and that further investigation was not warranted. I found that frustrating. The phenomenon was clearly real. The photographs were legitimate, but without a physical explanation, there was nothing more I could do." Reflection. Lakes remains a popular photography destination. Thousands of visitors take pictures there each year. In online forums dedicated to landscape photography, occasional posts appear from people who claim to have captured unusual reflections at the location. Most are easily explained as lens flares, water disturbances, or processing artifacts. None match the clarity and consistency of the 1991 inversions. Marcus Sorensen kept a single print from the original roll, a photograph he had not submitted to the Park Service. It shows his daughter Ingrid standing near the water's edge, smiling. Behind her, the mountain is clear. In the lake, the storm is visible. He framed the photograph and hung it in his study. When visitors ask about it, he tells them the story. Most assume it's a darkroom trick. He no longer corrects them. There are languages that exist only in the spaces between trees. The Carbon River Valley cuts into the northwest corner of Mount Rainier National Park, a temperate rainforest corridor that receives more than 90 inches of precipitation annually. Old-growth cedars and Douglas firs rise from a forest floor thick with moss and ferns. The river itself is glacier-fed, milky gray with suspended sediment, and prone to sudden floods when warm weather accelerates snowmelt on the Carbon Glacier above. The valley floor is narrow, rarely more than half a mile wide, and bounded by steep slopes that trap moisture and create a perpetual canopy gloom even at midday. The area was logged selectively in the early 1900s before its inclusion in the national park. Remnants of that era remain: rusted cable, rotting bridge pilings, a few overgrown railway grades. But by the mid-20th century, the forest had largely reclaimed itself. The Carbon River Road, built in 1921, provided vehicle access until 2006, when repeated flood damage forced its permanent closure to cars. Since then, the valley has become one of the quieter sections of the park, visited mostly by hikers willing to walk the washed-out roadbed. Indigenous groups, including the Puyallup and Nisqually, traditionally avoided extended stays in the Carbon River drainage. Oral histories reference the valley as a boundary zone, neither fully inhabited nor entirely forbidden, but treated with caution. An anthropologist named Dr. Elena Vargas, working with tribal elders in the 1970s, documented stories of voices that speak backward associated with the upper Carbon River, though the exact meaning of this phrase was unclear and debated among the communities themselves. On August 12, 2003, a three-person Forest Service team entered the Carbon River Valley to conduct a wildlife habitat assessment. The survey was part of a larger study examining spotted owl populations and old-growth forest health. The team consisted of Marcus Delgado, a wildlife biologist with 11 years of field experience, Nadia Kowalski, a forest technician specializing in plant ecology, and Henrik Johansson, a graduate student from Oregon State University, completing his thesis research on moss biodiversity. The group carried standard field equipment, GPS units, binoculars, plant presses, notebooks, and a digital audio recorder for documenting bird calls and ambient forest sounds. The recorder, a Sony PCM-M1, was capable of capturing high-quality audio and was frequently used in wildlife surveys to identify species by sound. Henrik was responsible for the audio documentation. He started recording shortly after the team entered the forest at 9:30 a.m. The day was overcast but dry. Visibility in the forest was poor due to fog drifting through the canopy. The team followed an unmarked path along the north bank of the river, stopping periodically to document plant species and search for owl pellets. By noon, they had traveled approximately 3 miles from the trailhead. Marcus later estimated their position as roughly halfway between the park boundary and the snout of the Carbon Glacier, in an area where the forest was particularly dense. At 12:47 p.m., according to the recorder's timestamp, Henrik's equipment picked up something unusual. The team had stopped for lunch near a grove of western red cedars. Henrik had left the recorder running to capture ambient sound, a standard practice meant to document the acoustic environment of the study site. The recording continued for 17 minutes. When Henrik reviewed the audio that evening, he heard voices. The voices were faint but distinct. There were at least 3 speakers, possibly more. The cadence suggested conversation pauses, overlapping speech, intonation patterns consistent with questions and responses, but the language was unrecognizable. Henrik, who spoke English, Spanish, and some Norwegian, could not identify a single word. The voices did not sound distorted or electronically altered. They sounded human clear, articulate, and entirely unintelligible. Henrik brought the recording to Marcus and Nadia. All 3 listened to it multiple times. None recalled hearing voices in the forest that afternoon. The area had been quiet. No other hikers. No nearby trails. The voices in the recording did not sound distant or muffled as one would expect from people speaking elsewhere in the forest. They sounded close, as if the speakers were within 20 or 30 feet of the microphone. Marcus contacted the Mount Rainier National Park headquarters the following day. He explained the situation to the chief ranger, a woman named Lillian Mbara, who had been with the Park Service for 16 years. Mbara asked Marcus to submit a copy of the recording along with a written report detailing the survey team's activities that day. Marcus complied. The recording was logged as unidentified audio anomaly and forwarded to the Park Service's regional office in Seattle. Nadia Kowalski later described her reaction to the voices as deeply unsettling. In a 2009 interview, she said, "It wasn't just that we couldn't understand the language. It was that we hadn't heard anything while we were there. We were sitting 10 feet from the recorder. If people had been talking that close to us, we would have heard them. But there was nothing, just the sound of the river and some birds. Henrik Johansson was more analytical. I checked the equipment afterward, he said. No malfunctions, no interference. The recorder had been sitting on a flat rock, untouched. The microphone was directional, pointed into the forest. Whatever it picked up was real, in the sense that sound waves reached the microphone and were recorded. But I have no explanation for the source. Marcus Delgado focused on the practical impossibility of the situation. We were miles from any road, he said. The nearest trail junction was 2 miles back. We saw no one that day. And even if someone had been nearby, why would we not have heard them? Sound carries in that forest. You can hear a branch snap from 100 yards away. The Park Service sent the recording to the University of Washington Department of Linguistics in September 2003. A graduate student named Yuki Tanaka was assigned to perform an initial analysis. Tanaka's training was in phonetics and language documentation. She had worked with endangered languages in the Pacific Northwest and was familiar with indigenous dialects from the region. Her analysis took 3 weeks. Tanaka's preliminary report, submitted in October 2003, identified several key features of the recorded voices. First, the audio contained clear phonetic structure, distinct consonants and vowels, arranged in patterns consistent with human speech. Second, the recording exhibited grammatical markers, such as word boundaries, sentence final intonation, and turn-taking between speakers. Third, certain sound sequences repeated across the recording, suggesting vocabulary or grammatical particles. However, Tanaka could not match the language to any known dialect. She compared the recording to databases of indigenous languages from the Pacific Northwest, including Lushootseed, Sahaptin, and Chinook jargon. None matched. She consulted with colleagues specializing in Asian, European, and African languages. No matches were found. In her report, she wrote, "The recording contains what appears to be a structured language, but it does not correspond to any documented human language in our comparative databases." The university expanded the analysis. Dr. Helena Ilunga, a professor of historical linguistics, reviewed the recording in November 2003. She noted that some phonetic features, certain vowel qualities and consonant clusters, were rare or absent in known languages, but not impossible for human vocal anatomy to produce. "It's a language," she said in an interview years later. "I'm certain of that, but it's not one I've ever encountered, and I've studied hundreds." Dr. Amara Okafor, a specialist in computational linguistics, ran the audio through pattern recognition software designed to detect language structure. The software confirmed the presence of recurring phonemes and grammatical patterns. "The algorithm treats this as a language," Okafor said. "It identifies word-like units, sentence boundaries, and statistical regularities consistent with syntax. By every measure we use to define language, this recording contains one." The Park Service contacted the Federal Bureau of Investigation in December 2003 to inquire whether the voices might be related to illegal activity in the park, poaching, drug trafficking, or trespassing. An agent reviewed the recording and concluded it was not actionable as evidence of criminal activity. The FBI had no record of similar audio anomalies in the region. In January 2004, the Park Service submitted a request to the Smithsonian Institution for additional linguistic analysis. The Smithsonian's Department of Anthropology reviewed the recording and consulted with linguists specializing in undocumented and extinct languages. Their response, delivered in March 2004, stated, "While the recording exhibits features consistent with language, we cannot identify its origin. It does not match any language in our archives, including extinct or reconstructed languages." The university team attempted to create a phonetic transcription of the recording. This process, converting speech sounds into written symbols, is standard in linguistic documentation, but the transcription proved difficult. Some sounds in the recording fell between standard phonetic categories, making them hard to represent accurately. Dr. Tanaka noted that certain segments sounded layered, as if multiple voices were speaking simultaneously in a way that made individual words difficult to isolate. One detail troubled the researchers. In several places, the recording appeared to contain echoes or repetitions that did not match the acoustic properties of the forest. Dr. Okafor described this as impossible given the environment. An echo in a dense forest typically dissipates quickly, absorbed by trees and undergrowth. But in the recording, certain phrases seemed to repeat with clarity, as if bouncing off hard surfaces that did not exist. The Park Service requested that the Forest Service team return to the Carbon River site in June 2004 to attempt a follow-up recording. Marcus Delgado and Nadia Kowalski agreed to participate. Henrik Johansson had graduated and moved to Alaska. The team, accompanied by a Park Service ranger named Jamal Bergstrom, hiked to the approximate location where the original recording had been made. They used GPS coordinates to position themselves as accurately as possible. The team recorded audio for 6 hours over 2 days. They captured river sounds, bird calls, wind in the canopy, and the distant rumble of rockfall from the glacier. No voices were recorded. The forest was, according to their reports, entirely normal. In 2005, the Park Service reclassified the Carbon River recording as unexplained audio phenomenon and transferred the file to long-term storage. A note in the file indicated that further investigation is not considered feasible given the lack of reproducible evidence. Attempts to obtain the original recording in subsequent years were unsuccessful. Freedom of Information Act requests, filed in 2007 and 2011, received responses stating that the audio file could not be located in Park Service archives. The University of Washington confirmed it had returned all copies to the Park Service in 2004 and did not retain duplicates. Dr. Helena Ilunga, before her retirement in 2018, was asked by a journalist whether she believed the voices were human. She paused before answering, "I don't know what else they could be," she said. But human doesn't necessarily mean contemporary or local. Marcus Delgado continued working for the Forest Service until his retirement in 2019. He returned to the Carbon River Valley multiple times over the years, always carrying an audio recorder. He never captured anything like the original recording. In a final interview before retiring, he said, "I've spent hundreds of hours in that forest. It's one of the quietest places I know. But every time I'm there, I stop and listen, and I wonder if they're still talking." The Carbon River Valley remains accessible to hikers. The forest is unchanged, dense, wet, silent, and somewhere in a storage facility, or perhaps lost entirely, a recording exists of 17 minutes, during which the forest spoke in a language no one has been able to name. Time does not always move at the speed we expect. The Sunrise Visitor Center sits at 6,400 feet on the northeast flank of Mount Rainier, the highest point in the national park accessible by vehicle. The facility was built in 1966 to replace an older log structure that had served tourists since the 1930s. The new building was designed in the style of mid-century park architecture, low-slung, angular, with large windows facing the mountain and surrounding meadows. During summer months, Sunrise serves as a hub for hikers, climbers, and tourists seeking access to trails that lead into the Cascade Wilderness. The elevation at Sunrise creates its own climate. Temperatures rarely exceed 70 degrees even in July. Snow can fall in any month. The meadows bloom briefly in late summer lupine, paintbrush, avalanche lilies before frost returns. The parking lot fills early on clear days. By afternoon, clouds often move in, obscuring the summit and dropping visibility to near zero within minutes. Mount Rainier, has been the site of numerous disappearances and unexplained incidents since the park's establishment in 1899. The mountain's weather, terrain, and glacial crevasses account for most documented tragedies. But there are cases that remain unresolved: hikers who vanished on clear days, aircraft that disappeared without distress signals, reports of lights and sounds that have no obvious source. The Park Service maintains files on these incidents but rarely discusses them publicly. In late June of 1994, a seasonal ranger named Thomas Delgado was assigned to the Sunrise Visitor Center for the summer. Delgado had worked at various national parks for 7 years and was known for his attention to detail. One of his responsibilities was maintaining the visitor center's logbook, a record of daily operations, weather conditions, and visitor counts. He kept the log with precision, noting arrival and departure times, temperature readings, and any incidents requiring ranger intervention. On June 28, 1994, Delgado noticed something unusual about the wall clock in the visitor center's main hall. The clock, a simple analog timepiece with black hands and white face, showed 1:11 p.m. when Delgado locked the building for the night. His wristwatch, a Timex he had owned for 5 years, showed 12:59 a.m. He assumed the wall clock was fast and made a note to adjust it the following morning. The next day, June 29th, Delgado arrived at the visitor center at 7 a.m. The wall clock read 7:12. His wristwatch showed 7 a.m. exactly. Curious, he checked the clock against the radio-synchronized time display on the visitor center's desktop computer. The computer showed 7 a.m. Delgado reset the wall clock to match. When he left that evening at 6 p.m., the wall clock showed 6:13. His watch showed 6 p.m. Delgado documented the discrepancy in his logbook. Over the next week, he checked the clock daily and found the same pattern. The clock gained approximately 11 minutes every 24 hours. He replaced the battery. The behavior continued. He borrowed a different analog clock from the ranger station at White River and hung it next to the original. Both clocks gained 11 minutes per day, staying synchronized with each other, but not with actual time. In mid-July, Delgado mentioned the clocks to his supervisor, a woman named Helena Okafor, who had been with the Park Service since 1986. Okafor was skeptical, but agreed to observe the phenomenon herself. She brought her own wristwatch, a Swiss-made mechanical watch her father had given her, and left it in the visitor center overnight. When she retrieved it the following morning, the watch had gained 11 minutes. Her digital watch, left beside the mechanical one, kept accurate time. Okafor expanded the test. She asked several rangers and volunteer staff to bring various timepieces into the visitor center and monitor them throughout the day. By the end of July, the results were consistent. Any analog clock or mechanical watch kept inside the Sunrise Visitor Center gained 11 minutes per 24-hour period. Digital devices, watches, computers, phones were unaffected. The phenomenon was specific to the building. Timepieces left in the parking lot or on the surrounding trails kept accurate time. A ranger named Jamal Rousseau conducted an experiment in which he carried a mechanical watch from the parking lot into the visitor center, wore it for 8 hours, then returned to his vehicle. The watch gained approximately 5.5 minutes during the time spent inside. Rousseau repeated the test twice with identical results. Word of the clocks spread among park staff. Some found it amusing, a quirk to mention in casual conversation. Others were unsettled. A visitor services assistant named Priya Vargas refused to wear her watch inside the building after noticing it consistently ran fast by the end of her shifts. It felt wrong. She said in a 2001 interview, "Not dangerous, just wrong." Like something about the building was out of sync with the rest of the world. Thomas Delgado began keeping detailed records. He logged which timepieces were tested, where they were placed within the building, and how much time they gained. He noted that the effect seemed uniform throughout the structure clocks. In the main hall, the back offices, and the restrooms all gained the same 11 minutes. Temperature fluctuations, barometric pressure, and visitor traffic had no measurable impact. By September 1994, Delgado had compiled 43 pages of observations. He submitted his findings to the Park Service Regional Office in Seattle, expecting them to be filed as a minor operational anomaly. Instead, his report was forwarded to the National Park Service's Natural Resources and Science Division, which in turn contacted the National Institute of Standards and Technology. NIST is the federal agency responsible for maintaining official time standards in the United States. The agency's laboratories in Boulder, Colorado, house the atomic clocks that define the nation's timekeeping systems. When contacted by the Park Service in October 1994, NIST expressed interest in the sunrise phenomenon, but could not immediately allocate resources for an investigation. Throughout 1995, the clocks at sunrise continued to gain 11 minutes per day. Park staff adjusted to the oddity. Analog clocks were reset daily. Rangers relied on digital watches for official timekeeping. Visitors occasionally asked why the wall clock was wrong. Staff offered vague explanations about altitude affecting mechanical movements, though no one believed this was scientifically accurate. A journalist named Marcus Bergstrom, writing for a regional outdoor magazine, visited Sunrise in August 1995, after hearing about the clocks from a park volunteer. Bergstrom brought a vintage pocket watch and left it at the visitor center desk for 12 hours, while he hiked nearby trails. When he returned, the watch had gained 5.5 minutes. He wrote a brief article about the experience, which appeared in the magazine's November issue. The article generated mild interest, but no significant attention. In March 1996, NIST approved funding for a field investigation. A 3-person team arrived at Mount Rainier in July, after the Sunrise Road had been cleared of winter snow. The team consisted of Dr. Yuki Tanaka, a physicist specializing in time measurement, Dr. Amara Singh, an engineer with expertise in electromagnetic fields, and a graduate student named David Kowalski, whose dissertation focused on environmental factors affecting precision instruments. The team spent 2 weeks at Sunrise, conducting tests with a variety of timekeeping devices. They brought cesium beam atomic clocks, quartz oscillators, mechanical chronometers, and consumer-grade analog watches. They placed instruments throughout the visitor center and in surrounding areas. They measured electromagnetic fields, gravitational variations, seismic activity, and atmospheric conditions. They interviewed park staff and reviewed Thomas Delgado's logs. Their findings, completed in September 1996, confirmed the anomaly. Mechanical timepieces inside the Sunrise Visitor Center consistently gained time relative to atomic clocks positioned outside. The rate was precise 11 minutes per 24-hour period, with a margin of error less than 5 seconds. Digital devices showed no discrepancy. The team ruled out several possible causes. There was no detectable electromagnetic interference that would affect mechanical movements. Gravitational measurements showed no anomalies. The building's structure, materials, and electrical systems offered no obvious explanation. Temperature and humidity inside the visitor center were well within normal ranges for mechanical watch operation. Dr. Tanaka's report noted one peculiarity. In controlled laboratory conditions, when a mechanical watch runs fast, the rate of time gain typically varies depending on position, temperature, and wear. The watches at Sunrise gained time at a perfectly consistent rate, regardless of brand, age, or condition. This uniformity is unexpected. Tanaka wrote, "It suggests an external influence affecting all mechanical oscillators equally, but we have been unable to identify the source of this influence." Dr. Singh investigated whether the building's location at high elevation on an active stratovolcano might create unique gravitational or magnetic conditions. She found no evidence to support this hypothesis. Mount Rainier's volcanic activity is closely monitored by the USGS. No unusual readings coincided with the timekeeping anomaly. The team's final report submitted to NIST in October 1996, ran to 87 pages and included extensive data tables, graphs, and technical analysis. The conclusion was brief. We have documented a reproducible phenomenon in which mechanical timepieces gain approximately 11 minutes per 24-hour period when located inside the Sunrise Visitor Center. We have not identified a physical mechanism that would produce this effect. Further investigation is recommended. NIST forwarded the report to the Park Service with a recommendation that the Sunrise Visitor Center to be monitored for any additional anomalies. The Park Service acknowledged receipt and filed the report under administrative records. In November 1996, Helena Okafor received a letter from the Park Service Regional Director stating that the timekeeping irregularity at Sunrise does not pose a safety risk to visitors or staff and does not require operational changes. In early 1997, the phenomenon stopped. Thomas Delgado, still stationed at Sunrise, noticed in late April that the wall clocks were keeping accurate time. He tested his own mechanical watch. No time gain. He asked other rangers to test their timepieces. All kept correct time. The 11-minute daily gain had ceased, as abruptly and inexplicably as it had begun. Delgado reported this to Helena Okafor, who contacted NIST. Dr. Tanaka returned to Sunrise in June 1997 with portable atomic clocks and test instruments. She spent 4 days conducting measurements. Everything was normal. Mechanical watches kept accurate time. No anomalies were detected. In her follow-up report, Tanaka wrote, "The phenomenon observed between June 1994 and April 1997 is no longer present. Without ongoing manifestation, further investigation is not feasible. The cause remains undetermined." NIST classified the Sunrise investigation under a designation used for unexplained phenomena that cannot be studied due to lack of reproducibility. The full report was not released to the public. Freedom of Information Act requests filed in 2004 and 2012 received partial documentation with key sections redacted. The reason given was inconclusive scientific findings not suitable for public interpretation. Thomas Delgado left the Park Service in 2002. Before his departure, he donated his logbooks from the Sunrise years to the park's historical archive. Researchers can view the logs by appointment, though few do. The entries are meticulous. Daily records of time discrepancies, lists of tested timepieces, notes on weather and visitor activity. The logs end in April 1997 with a final notation. Wall clock accurate. No gain. Phenomenon ceased. The Sunrise Visitor Center remains operational. Thousands of visitors pass through each summer. The building has been renovated twice since the 1990s, but the basic structure is unchanged. A wall clock still hangs in the main hall. It keeps perfect time. Helena Okafor retired in 2015. In a brief interview 3 years later, she was asked if she had any theories about the clocks. She paused before answering. "I don't," she said. "And that's what I think about most. Not that it happened, but that it stopped. Things that start for no reason and stop for no reason, those are the ones that stay with you." Some paths were walked long before there were names for the mountain. Disappointment Cleaver is a prominent rock ridge on Mount Rainier's southeast flank, rising between the Ingraham and Emmons glaciers, at elevations between 10,000 and 12,000 feet. The feature earned its name in the early 20th century, when climbers mistook it for the summit ridge, only to discover upon reaching it that the true peak remained more than 2,000 feet above. The Cleaver serves as the primary route for modern summit attempts via the Ingraham Direct, a steep and technical climb requiring ice axes, crampons, and experience with crevasse navigation. The first documented ascent of Mount Rainier occurred in 1870, though indigenous accounts suggest the mountain's lower slopes were visited for centuries before European contact. The Puyallup, Nisqually, Yakama and Cowlitz peoples all maintained traditional relationships with the mountain, which they knew by names, that translate roughly as the mountain that was God, or the place where the waters begin. Oral histories describe spiritual significance, but also caution the upper mountain was not a place for extended human presence. Disappointment Cleaver itself is a stark landscape. Exposed volcanic rock, wind-scoured and fractured, gives way to permanent ice fields. The glaciers on either side calve regularly, sending house-sized blocks tumbling into bergschrunds below. Weather changes without warning. Climbers caught in whiteout conditions have walked off ledges they could not see. The route claims lives nearly every decade falls. Avalanches, altitude sickness, hypothermia. Bodies are sometimes recovered. Others remain in the ice. On August 14, 2001, a guided expedition of 7 climbers was ascending Disappointment Cleaver en route to the summit. The group consisted of 5 clients and 2 guides from Rainier Mountaineering Incorporated, the primary guiding service operating on the mountain since 1969. The lead guide was a man named Thomas Kowalski, who had summited Rainier more than 300 times over a 15-year career. His assistant was a younger guide named Helena Vargas, in her 4th season on the mountain. The group had left Camp Muir at 1 a.m., a standard departure time designed to reach the summit by mid-morning and descend before afternoon storms developed. By 6:30 a.m., they had ascended to approximately 11,200 feet, moving in a rope team configuration across a section of glacier adjacent to the Cleaver's east side. Visibility was good. The sky was clear. Temperature was near 10 degrees Fahrenheit. Kowalski, leading the rope team, stopped abruptly. He raised his hand to signal the others to halt. Later, he would describe what he saw as immediately wrong. Pressed into the ice ahead of him was a line of footprints, bare human footprints, clearly defined, leading upward across the glacier toward the summit ridge. The prints were not fresh. They were embedded in ice that showed signs of age, small surface cracks, a slightly opaque quality that indicated compression over time, but they were unmistakable. Each print showed 5 toes, a heel, and an arch. The stride length was consistent, approximately 4.5 feet from heel to heel. The prints followed a nearly straight line up the slope, angling slightly to avoid a visible crevasse. Kowalski examined the first print closely. The ice around it was solid, undisturbed. He pressed his gloved hand into the surface nearby. It left no impression. The ice was too hard, too old. He called Helena Vargas forward. She saw the same thing. Both guides were experienced enough to recognize that footprints in glacial ice were impossible under normal circumstances. Ice flows, deforms, and recrystallizes. Surface features disappear within weeks, buried under new snow or erased by wind. These prints were deep nearly 2 inches and perfectly preserved. The group followed the prints for approximately 400 meters. The clients, initially curious, became uneasy. One of them, a software engineer from Seattle named Marcus Desjardins, later described the prints as too perfect, like they'd been carved. Another client, a teacher from Portland named Nadia Rousseau, said the prints made her feel watched, though there was no one else on the mountain. The footprints ended at a crevasse, a deep fissure in the glacier that dropped out of sight into blue darkness. The final print was at the edge, toes pointing into the void. Beyond the crevasse, on the far side, there were no prints. Kowalski peered into the gap. No body was visible, no equipment, just ice and shadow. The group continued to the summit, reaching it by 9 a.m. On the descent, they returned to the location where the prints had been. Kowalski took photographs. He measured the stride length using a length of rope. He noted the coordinates using a handheld GPS unit. The prints remained exactly as they had appeared earlier, clear, deep, undisturbed. Upon returning to base, Kowalski reported the discovery to the National Park Service. A ranger named Jamal Bergstrom reviewed the photographs and contacted the Park Service's Chief of Resources, a woman named Dr. Amara Okafor. Okafor, a geologist with a background in glaciology, found the images troubling. She arranged for a follow-up expedition to the site. On August 19, 2001, a team consisting of Okafor, Kowalski, and a visiting glaciologist from the University of Washington, named Dr. Yuki Tanaka, returned to Disappointment Cleaver. They carried ice cores, camera equipment, and GPS units. They located the footprints using Kowalski's coordinates. The prints remained visible and unchanged. Tanaka extracted ice core samples from within and around the prints. Analysis later showed that the ice containing the prints was significantly older than surface ice in the area, estimated at between 700 and 900 years based on isotopic composition and density. The surface layer of the glacier at that elevation typically accumulates and ablates on a seasonal cycle. Old ice is buried deep below, but these prints were at the surface, in ice that predated European contact with the continent. Dr. Tanaka described the situation in her preliminary report as geologically inconsistent. She wrote, "The prints exist in ice that should be buried under centuries of accumulation. Their presence at the surface suggests either recent exposure through unusual ablation or an event I cannot explain using conventional glaciology." The photographs were sent to Dr. Helena Ibarra, a forensic podiatrist at the University of California, Davis, who specialized in gait analysis and historical footprint interpretation. Ibarra examined the images and provided a detailed report. In October 2001, she noted that the stride length 4.5 feet was significantly longer than average for modern humans, which typically ranges between 2.5 to 3.5 feet during normal walking. The depth and pressure distribution suggested a body weight of at least 250 pounds, yet the foot size appeared consistent with an adult human male of average build. "The biomechanics are unusual," Ibarra wrote. "A stride of this length would require either an individual of extraordinary height, over 7 feet, or a running gait. But running barefoot across glacial ice at 11,000 feet is not survivable. The feet would sustain immediate frostbite. The prints show no signs of slipping or imbalance, which would be expected in running. I cannot reconcile the stride length with the apparent walking gait." The Park Service contacted the Puyallup Tribal Historic Preservation Office in September 2001 to inquire whether the footprints might be connected to indigenous oral histories. Tribal representatives reviewed the photographs and consulted with elders. A written response, delivered in November, acknowledged that stories existed of ancient travelers on the mountain, but specifics were either not shared or had been lost over generations. The response noted that some paths on the mountain are older than memory. In December 2001, the Park Service classified the footprints as unexplained geological phenomenon and restricted further access to the site. Kowalski was asked not to discuss the discovery publicly. Okafor's report was filed under administrative records with a notation that additional investigation would require specialized equipment and funding not currently available. Attempts by outside researchers to study the footprints were denied. Dr. Tanaka requested permission to return to the site in 2002 with advanced ice-penetrating radar to map subsurface features. Her request was declined. Dr. Ibarra applied for a research permit to study the prints in person. The Park Service responded that the site is no longer accessible due to seasonal conditions. In 2003, a climbing team reported seeing footprints near the same location. Their description matched the original discovery barefoot prints in old ice, leading upward, ending at a crevasse. They did not photograph them. The Park Service logged the report but did not follow up. Thomas Kowalski left Rainier Mountaineering Incorporated in 2005. In a 2012 interview with an outdoor magazine, he said, "I've climbed that route 100 times since. I've never seen the prints again, but I think about them. I think about who made them and when, and why they were going up instead of down. You don't walk barefoot on a glacier. You don't survive it. But someone did. Helena Vargas, who witnessed the footprints as assistant guide, declined multiple interview requests. In a brief email to a journalist in 2009, she wrote, "I saw what I saw. I don't have an explanation. I don't think anyone does." Dr. Amara Okafor retired from the Park Service in 2016. Before leaving, she transferred her files to the park's archive facility in Longmire. Among them was a folder labeled Disappointment Cleaver, August 2001. The folder contained Kowalski's photographs, Tanaka's ice core analysis, Imbara's biomechanical report, and a handwritten note from Okafor that read, "No further action recommended. Phenomenon not reproducible." The photographs remain in the archive, accessible only by special request and Park Service approval. Requests are rarely granted. The ice core samples were stored at the University of Washington until 2010, when they were transferred to an undisclosed federal facility for long-term preservation. Their current location is not publicly documented. Disappointment Cleaver continues to serve as the primary summit route. Thousands of climbers ascend it each season. The glaciers shift and flow, covering old ice with new snow, erasing surface features, creating and closing crevasses. And somewhere in that moving river of ice, preserved in layers that should not exist at the surface, a line of footprints leads toward the summit bare feet, pressing into frozen time, walking a path no modern human should have survived. There are rhythms in the earth that follow calendars we did not create. Longmire sits at 2,700 feet in the southwest corner of Mount Rainier National Park, nestled in a valley where the Nisqually River bends through old-growth forest. The area is named for James Longmire, a settler who discovered mineral springs there in 1883 while guiding climbers toward the mountain. The springs became the foundation of a small resort, the Longmire Springs Hotel, built in 1884 and expanded over subsequent decades to accommodate tourists seeking the purported healing properties of the thermal waters. The springs emerge from fractured bedrock near the base of Rampart Ridge, fed by geothermal activity related to Mount Rainier's volcanic system. The water is naturally warm, rich in minerals, and flows at a consistent rate throughout the year. By the early 20th century, Longmire had become the primary entry point to the national park, with a ranger station, visitor center, and museum eventually replacing the aging hotel structures. The springs themselves were preserved, channeled into small pools, and protected from development. Mount Rainier is classified as an active stratovolcano, one of the most hazardous peaks in the Cascade Range due to its extensive glaciation and potential for Lahar's volcanic mudflows. The geothermal system beneath the mountain is monitored continuously by the United States Geological Survey. Heat flow, ground temperature, and gas emissions provide data used to assess volcanic risk. Longmire's springs are part of this system, minor thermal features compared to the fumaroles and steam vents higher on the mountain, but nonetheless connected to the same geothermal sources. In October of 1889, a naturalist named Edwin Vargas was conducting a survey of the Longmire area for the Smithsonian Institution. Vargas kept meticulous records, temperature readings, water flow rates, mineral content, seasonal variations. He visited the springs daily throughout the fall and winter of 1889 and 1890. On February 9, 1890, he recorded an anomaly in his field notes. The water temperature in the main spring had dropped from 78 degrees Fahrenheit to 34 degrees between the hours of 9 a.m. and noon. By 1 p.m., the temperature had returned to 78 degrees. Vargas assumed he had made an error in measurement. He checked his thermometer against a second instrument. Both read the same. He noted the incident but did not immediately report it as significant. However, on February 9, 1891, while conducting follow-up research, he measured the springs again. The same drop occurred 78 degrees to 34 degrees 9 a.m. to noon, then back to 78 degrees by 1 p.m. Vargas documented the pattern over the next 3 years. Every February 9th, the springs cooled to 34 degrees for exactly 3 hours, then returned to their baseline temperature. He published a brief paper in 1894 describing the phenomenon, attributing it tentatively to seasonal geothermal fluctuations of unknown origin. The paper received little attention. Thermal springs were poorly understood at the time. Vargas left the region in 1895 to work elsewhere. His notes were archived at the Smithsonian. The Longmire Springs Hotel operated until 1919, when the National Park Service acquired the property. During the hotel's operational years, staff occasionally remarked on the February temperature drop, but it was treated as a curiosity rather than a scientific concern. Guests who visited the springs on February 9th sometimes complained that the water was cold. Management attributed this to weather conditions or plumbing issues, though no maintenance records document any problems with the spring's infrastructure. By the mid-20th century, the springs were no longer used for bathing. They were preserved as a historical and natural feature, accessible to visitors, but not developed for recreation. Park rangers occasionally measured water temperature as part of routine monitoring, but detailed records were not consistently maintained. In 1973, a geologist named Dr. Helena Mbarra was conducting a study of geothermal features in Mount Rainier National Park. She had read Vargas's 1894 paper and was curious whether the February 9th anomaly persisted. On February 9, 1973, she visited Longmire with calibrated thermometers and data loggers. She measured the spring temperature hourly from 8 a.m. to 2 p.m. At 9 a.m., the temperature was 78 degrees. At 10 a.m., it was 35 degrees. At 11 a.m., 34 degrees. At noon, 34 degrees. At 1 p.m., 77 degrees. By 2 p.m., it had stabilized at 78 degrees. The cooling occurred without any visible change in water flow, steam production, or surrounding ground temperature. Mbarra placed thermometers in adjacent soil and nearby streams. Those temperatures remained stable. Only the spring itself cooled. Mbarra returned to Longmire on February 9th for the next 4 years, 1974 through 1977. Each year, the pattern repeated exactly. She expanded her measurements to include pH, mineral content, and dissolved gas concentrations. None of these parameters changed during the temperature drop. The water simply became cold for 3 hours, then returned to normal. Her findings were published in a 1978 paper in the Journal of Geothermal Research. The paper included graphs, temperature logs, and chemical analysis. Mbarra concluded, "The Longmire Springs exhibit an annual thermal anomaly that cannot be explained by known geothermal processes. The cooling is precise in timing and duration, suggesting a mechanism that operates independently of ambient conditions or volcanic activity. I have no hypothesis to offer." The paper prompted interest from other geologists. Dr. Thomas Rousseau, a volcanologist from the University of Washington, visited Longmire in February 1979 with seismic equipment and infrared cameras. He documented the temperature drop and found no corresponding changes in subsurface heat flow or seismic activity. "The geothermal system beneath Longmire should not behave this way," he said in a 1980 interview. Thermal springs are fed by deep groundwater heated by magma or geothermal gradients. Those heat sources don't turn off for 3 hours once a year and then turn back on. It's not how geology works. Dr. Amara Kowalski, a hydrologist specializing in groundwater systems, conducted tracer studies at Longmire in the early 1980s. She introduced non-toxic dyes into the spring's source area to map water flow paths. The dyes revealed that the spring was fed by a complex network of fractures extending several hundred feet underground. But the pathways did not explain the temperature anomaly. Water flowing through those fractures should maintain a relatively constant temperature, Kowalski said. It's insulated by rock. Seasonal air temperature fluctuations don't penetrate that deep. And even if they did, why would the cooling occur on one specific day every year? In 1986, the USGS installed permanent temperature sensors at Longmire as part of its volcanic monitoring network. The sensors recorded data continuously and transmitted it to a central database. On February 9, 1987, the sensors confirmed what had been observed manually for nearly a century. The spring temperature dropped from 78 degrees to 34 degrees between 9 a.m. and noon, then returned to 78 degrees by 1 p.m. The USGS expanded its monitoring. Additional sensors were placed in nearby springs, streams, and boreholes. Only the main Longmire spring exhibited the anomaly. Other thermal features in the park showed no unusual temperature variations. The USGS published technical reports documenting the phenomenon, but offered no explanation. A 1992 report stated, "The annual thermal event at Longmire Springs remains unexplained. It does not correlate with volcanic activity, seismic events, or meteorological conditions. The mechanism is unknown." Park rangers at Longmire became accustomed to the pattern. Some kept personal logs, noting the exact time the temperature began to drop and when it returned to normal. A ranger named Jamal Bergstrom, stationed at Longmire from 1995 to 2003, described the springs on February 9th as eerie. He said, "The water looks the same. It flows the same. But when you put your hand in, it's shockingly cold. And then, right around 1 p.m., you can feel it warming up. It happens fast, within 10 or 15 minutes. And then it's like nothing happened." Visitors to Longmire on February 9th sometimes noticed the cold water and asked rangers about it. Most rangers offered vague explanations about geothermal variability. Few discussed the precise annual recurrence. "People don't want to hear that we don't understand it," Bergstrom said. "They want an answer, but we don't have one." In 2007, a team of geophysicists from Stanford University requested permission to conduct an intensive study of the Longmire Springs. They proposed using ground-penetrating radar, electromagnetic surveys, and deep temperature probes to map the subsurface thermal structure. The Park Service approved the study. The team spent 2 weeks at Longmire in January and February 2008, including February 9th. Their equipment detected no anomalies in the subsurface. The geothermal gradient temperature increase with depth was consistent with volcanic regions. Groundwater flow patterns appeared normal. On February 9th, the spring temperature dropped as expected. The instruments recorded it, but nothing in the subsurface data explained why. The team's lead researcher, Dr. Yuki Desjardins, described the experience in a 2010 interview. "We threw every tool we had at it. We mapped heat flow, fluid movement, rock permeability. Everything pointed to a stable geothermal system. And yet, on February 9th, the spring just stops being hot. For 3 hours. Then it starts again." We left Longmire with more data than we arrived with, but no more understanding. The Stanford study was published in 2011. The conclusion was cautious. The Longmire Springs thermal anomaly is a well-documented and reproducible phenomenon that defies conventional geothermal theory. We recommend continued monitoring and consideration of non-standard hypotheses. What those non-standard hypotheses might be, the paper did not specify. In 2015, a journalist named Priya Tanaka wrote an article about the Longmire Springs for a regional science magazine. She interviewed geologists, park rangers, and reviewed historical records dating back to Vargas's 1889 observations. She noted that the anomaly had occurred every year for over 125 years, without exception. "That kind of precision is unnatural," she wrote. "Nature doesn't follow calendars. But something at Longmire does. The article generated brief public interest. A few online forums discussed theories: underground ice, seasonal aquifer shifts, tidal influences on groundwater. None of the theories withstood scrutiny. Ice would not form at that depth. Aquifer shifts would not produce such precise timing. Tidal forces affect coastal groundwater, not mountain springs 70 miles inland. The Park Service received requests from researchers and enthusiasts asking to visit Longmire on February 9th. Most were granted access, though the Park Service emphasized that the springs were a natural feature deserving of respect, not a spectacle. Each year, a handful of people gather at the springs. On the morning of February 9th, they bring thermometers. They watch the temperature drop, and then they watch it rise again. Dr. Helena Ibarra, who first documented the modern occurrence of the anomaly, retired in 2018. In her final interview before retirement, she was asked if she had ever developed a theory. She said, "I've thought about it for 45 years. I don't have an answer. What I do have is data, decades of it, showing the same thing over and over. February 9th, 9 a.m. to noon, the water goes cold. Why February 9th? I don't know. Why exactly 3 hours? I don't know. And after all this time, I've stopped expecting to find out. The Longmire Springs continue to flow. Tourists photograph them in summer. Hikers stop to rest nearby. And every year, on February 9th, the water temperature drops to 34 degrees for 3 hours, just as it has since at least 1889. The USGS sensors record it. Rangers measure it. And somewhere in the fractured bedrock beneath Rampart Ridge, something heat flow, water chemistry, an unknown mechanism operates on a schedule that began before anyone was keeping records and shows no sign of stopping. Glaciers flow in one direction, except when they do not. The Nisqually Glacier descends from the summit crater of Mount Rainier, flowing southwest for more than 4 miles, before terminating at approximately 4,700 feet in elevation. It is one of the most accessible glaciers in the park, visible from the Paradise and Longmire visitor areas. The glacier has been the subject of scientific study since the late 19th century, when early geologists began documenting its advance and retreat in response to climate fluctuations. By the mid-20th century, the Nisqually had become one of the most measured glaciers in North America, a benchmark for understanding glacial dynamics. Glaciers move under their own weight. Ice accumulates at higher elevations and flows downslope, deforming internally and sliding across bedrock. The movement is slow, typically a few inches to a few feet per year, but relentless. Objects on a glacier's surface travel downslope with the ice. Rocks, debris, and scientific equipment left on the glacier will gradually migrate toward the terminus. This principle is fundamental to glaciology and has been confirmed through thousands of observations worldwide. In May of 1983, a team from the United States Geological Survey installed survey markers on the Nisqually Glacier as part of a long-term study of glacial movement and mass balance. The team was led by Dr. Marcus Delgado, a glaciologist who had been studying Mount Rainier's ice fields since the early 1970s. The markers were metal stakes, each approximately 3 feet long, driven into the ice and affixed with reflective targets for optical surveying. 3 markers were placed in a north-south line across the glacier at an elevation of 6,200 feet, spaced roughly 100 feet apart. The markers' positions were recorded using theodolite's precision instruments that measure angles relative to fixed reference points on the surrounding ridges. The coordinates were documented in field notebooks and later transferred to USGS archives. The purpose of the markers was to track how the glacier's surface moved over time, providing data on flow velocity and direction. Similar marker systems had been used on the Nisqually and other glaciers for decades without incident. Dr. Delgado's team revisited the glacier annually through 1987, measuring the markers' positions and noting their downslope migration. The movement was consistent with expectations, approximately 12 to 18 inches per year, flowing southwest toward the glacier's terminus. After 1987, funding for the project was reduced and regular measurements ceased. The markers were left in place, their positions recorded in the USGS database. In June of 2008, a graduate student from the University of Washington named Helena Vargas was conducting research on glacial retreat in Mount Rainier National Park. She had obtained the USGS records from the 1980s and planned to relocate the original survey markers to compare their positions against historical data. Using GPS coordinates derived from the 1983 measurements, she hiked onto the Nisqually Glacier with a field assistant, a geology undergraduate named Jamal Rousseau. Vargas expected to find the markers far downslope, buried under decades of accumulated ice and snow, or possibly lost entirely if they had reached the terminus and been carried away by meltwater. She carried a metal detector and probing equipment. Instead, she found the markers on the surface, exposed and visible, approximately 200 feet upslope from their original positions. At first, Vargas assumed she had miscalculated the coordinates. She rechecked her GPS unit. The readings were accurate. She consulted the USGS field notebooks, which included detailed descriptions of the surrounding terrain, rock outcrops, ridge profiles, sightlines to distant peaks. The landscape matched. The markers were in the wrong place. More troubling, the three markers originally placed in a straight north-south line now formed a perfect equilateral triangle. Each marker was equidistant from the others, approximately 60 feet separating each point. Vargas measured the triangle repeatedly. The distances were exact, within inches. The geometry was too precise to be coincidental. Jamal Rousseau, who had accompanied Vargas, later described his reaction as disbelief. "We spent an hour checking and rechecking," he said in a 2010 interview. "Helena thought we'd made a mistake with the GPS. I thought maybe the old survey data was wrong. But the USGS records were clear. The markers had been in a straight line, 100 feet apart, pointing downslope. Now they were upslope, in a triangle." Vargas collected ice core samples from around each marker. She used a portable drill to extract cores approximately 6 feet deep. The ice surrounding the markers appeared undisturbed, clean, layered, and consistent with normal glacial ice formation. There were no voids, fractures, or irregularities that would suggest the markers had been physically moved or repositioned. The ice had formed around the markers as if they had been in their current positions for years. Helena Vargas contacted her thesis advisor, Dr. Amara Okafor, a glaciologist at the University of Washington, with 30 years of experience studying ice dynamics. Okafor reviewed the data and visited the site in July 2008. She brought additional surveying equipment and a team of 3 graduate students. They confirmed Vargas's findings. The markers had moved upslope and had rearranged themselves into an equilateral triangle. Okafor examined the ice cores. Laboratory analysis showed normal isotopic composition and density profiles. The ice was old, estimated at 15 to 20 years, based on accumulation rates, but there were no signs of melting, refreezing, or mechanical disturbance. "It's as if the markers migrated through solid ice," Okafor said in a 2009 journal article. But that's not physically possible. Ice doesn't part and then close around an object without leaving evidence. The team expanded their investigation. They searched USGS archives for any records indicating the markers had been moved or replaced. None were found. They contacted Dr. Marcus Delgado, who had placed the original markers in 1983. Delgado, retired and living in Oregon, confirmed that the markers had been installed as documented 3 stakes in a straight line, 100 feet apart, at 6,200 feet elevation. "I drove those stakes in myself," Delgado said in a recorded phone interview. "I checked their positions with a theodolite. The coordinates are in my field notes. If someone moved them later, it wasn't me or anyone on my team. And even if someone did, how would you move a steel stake through 15 feet of solid ice without leaving a trace? The National Park Service was notified in August 2008. A resources management specialist named Thomas Bergstrom reviewed the case and consulted with park geologists. The Park Service had no records of anyone accessing the markers after 1987. The Nisqually Glacier is within park boundaries and requires a climbing permit to access. Permit records from 1988 through 2007 showed no applications mentioning survey markers or glaciology research in that specific area. Dr. Yuki Tanaka, a physicist specializing in ice mechanics, was brought in to review the findings in late 2008. Tanaka examined the ice cores and studied photographs of the markers in situ. She considered several hypotheses: thermal expansion causing localized ice movement, seismic activity shifting the ice mass, or crevasse formation and closure, allowing the markers to migrate. None fit the evidence. Thermal expansion doesn't move objects upslope, Tanaka explained in a 2010 lecture. Seismic activity would leave fractures or disturbed layers in the ice. There's no evidence of that. Crevasses can swallow objects, but they don't rearrange them into geometric patterns 200 feet away. The USGS convened a review panel in early 2009. The panel included glaciologists, geophysicists, and survey specialists. They examined all available data, historical records, GPS measurements, ice core analyses, and photographic evidence. Their report, completed in June 2009, acknowledged the anomaly but offered no explanation. The summary stated, "The relocation and geometric arrangement of the Nisqually survey markers cannot be explained by known glacial processes. The ice surrounding the markers shows no evidence of disturbance. No seismic events were recorded in the area between 1983 and 2008. The phenomenon remains unexplained." The report was filed in USGS archives, but not published in peer-reviewed literature. A note attached to the file indicated that further investigation is contingent upon identification of a plausible physical mechanism. Attempts to obtain the original survey markers for detailed analysis were unsuccessful. In 2010, a team from the University of Alaska requested permission to remove one of the markers for laboratory examination. The Park Service denied the request, citing preservation of scientific resources and concern about disturbing the site. The markers remain on the glacier, though their exact coordinates are no longer publicly available. Dr. Amara Okafor published a brief article about the case in 2011 in the Journal of Glaciology. The article presented the facts without attempting to explain them. Peer reviewers questioned whether the original 1983 coordinates had been accurately recorded. Okafor defended the data, noting that USGS survey standards in the 1980s were rigorous and that Dr. Delgado's field notes included corroborating measurements. "The most unsettling aspect," Okafor wrote, "is the geometric precision. If the markers had simply moved due to some unknown process, we might expect random displacement. But they arranged themselves into a perfect triangle. That suggests intention, or at minimum, a process with geometric constraints we do not understand." Helena Vargas completed her thesis in 2012. The Nisqually marker anomaly was included as an appendix labeled Unresolved Phenomenon. She did not return to the glacier. In a 2015 interview, she said, "I went into glaciology because it's predictable. Ice flows downhill. It's simple physics. But those markers broke that rule, and I don't know what that means." Jamal Rousseau, who assisted Vargas in the initial discovery, left geology after completing his undergraduate degree. He now works in software development. In a 2018 email, he wrote, "I think about those markers sometimes, how they were upslope when they should have been down, how they formed a triangle when they'd been in a line. I don't believe in supernatural explanations, but I also can't explain what I saw." The Nisqually Glacier continues to retreat, losing mass each year as global temperatures rise. The terminus has withdrawn more than half a mile since the 1980s. The glacier's surface is constantly changing. New crevasses open, old seracs collapse, meltwater streams carve channels through the ice. And somewhere on that moving river of ice, 3 metal stakes remain, arranged in a triangle that should not exist, marking positions they should never have reached. There are places where signals go to die. Emmons Glacier flows down the northeast flank of Mount Rainier, the largest glacier by area in the contiguous United States. It descends from the summit crater at 14,410 feet to its terminus near 5,500 feet, covering more than 4 square miles of ice. The glacier is heavily crevassed, particularly in its upper reaches, where steep slopes and rapid ice flow create unstable seracs and yawning bergschrunds. The route across Emmons is used primarily by climbers attempting the mountain's less traveled northern approaches, technical ascents that require glacier travel experience and careful navigation. Mount Rainier's glaciers have been studied extensively since the late 19th century. Early surveyors mapped their extent, climbers documented their features, and by the mid-20th century, scientists were using the glaciers to study climate change and ice dynamics. Radio communication became standard equipment for climbing teams in the 1950s, allowing contact with base camps and emergency services. The technology was reliable, limited only by line of sight and terrain interference. In July of 1962, a climbing expedition led by a guide named Walter Okafor was ascending the Emmons-Winthrop route to the summit. The team consisted of 4 clients and 2 guides, all carrying handheld VHF radios for communication. At approximately 9,000 feet, near the center of the glacier's upper basin, Okafor attempted to radio the Park Service Ranger Station at White River to report their progress. His radio produced no signal. He assumed it was a battery issue and switched to a backup unit. That radio also failed to transmit or receive. The second guide, a woman named Helena Kowalski, tested her own radio. Nothing. All 3 radios showed power and appeared functional. Lights, indicators, and controls operated normally, but no communication was possible. The team continued upward, and within 15 minutes of moving away from the area, radio function returned. Okafor reported the incident to the Park Service upon his return, attributing it to possible equipment malfunction or atmospheric interference. Over the next 2 years, similar reports accumulated. Climbing teams crossing the upper Emmons Glacier reported dead zones where radios stopped working. The location was consistent, a broad area in the glacier's northeast quadrant, roughly centered on coordinates that placed it near a shallow depression in the ice. The Park Service logged the reports but took no immediate action. Radio interference in mountain environments was not uncommon, often caused by terrain-blocking signals or atmospheric conditions affecting propagation. In 1964, a Park Service ranger named Marcus Desjardins conducted a field test. He hiked onto the Emmons Glacier with multiple radios, testing them at intervals as he moved across the ice. At a specific location, approximately 9,200 feet in elevation, all radios ceased transmitting and receiving simultaneously. Desjardins marked the position using a survey tape tied to an ice stake. He moved 100 meters in various directions. Outside the affected area, the radios worked normally. Inside, they were silent. Desjardins measured the zone's approximate boundaries using pacing and compass bearings. The dead zone was roughly circular, with a radius of about 400 meters. He returned to the site the following week with a park geologist, a man named Thomas Vargas. They brought a portable radio transmitter and attempted to broadcast from within the zone. The signal did not propagate. A receiving station positioned on a nearby ridge detected nothing. Vargas examined the ice and bedrock. There were no obvious geological features that would block radio waves, no metallic deposits, no unusual rock formations. The glacier was typical of Mount Rainier's upper ice fields. compressed snow and ice layers, minimal debris, occasional crevasses. He noted the location in his field report and recommended further investigation. By 1968, the phenomenon was well known among local climbing guides. They referred to it informally as the dead spot or the silence. Guides planning routes across the Emmons factored it into their safety protocols, ensuring teams did not rely solely on radio communication while traversing that section of the glacier. Some guides avoided the area entirely, choosing alternate routes that skirted the zone's boundaries. In 1973, a climber named Jamal Rousseau, an electrical engineer by profession, experienced the radio silence firsthand. He carried a spectrum analyzer, a device used to detect and measure electromagnetic signals during his ascent. Inside the dead zone, his radios failed, as expected. But the spectrum analyzer showed no unusual interference, no strong electromagnetic sources, and no signal blocking. It was like the radios just stopped working for no reason. Rousseau said in a 1975 interview, "There was nothing on the spectrum that would cause that. The air was electromagnetically quiet. The radios should have worked." Rousseau shared his findings with researchers at the University of Washington. A physics professor named Dr. Amara Tanaka reviewed the data and found it perplexing. "Radio silence usually has a cause," she said. "Interference from another transmitter, absorption by water or rock, reflection by terrain." But Jamal's data showed none of that. The radios were functional. The environment was clear. They just couldn't communicate. In 1976, the Federal Aviation Administration documented an incident involving a small aircraft flying over the Emmons Glacier. The pilot, a man named David Bergstrom, was conducting a scenic flight when his navigation instruments briefly malfunctioned while passing over the upper glacier. His GPS unit flickered. His radio lost contact with air traffic control for approximately 30 seconds, and his altimeter showed erratic readings. Once he cleared the area, all instruments returned to normal. Bergstrom filed a report with the FAA, noting the coordinates of the interference. The coordinates matched the location of the radio dead zone on the glacier. The FAA investigated. They reviewed radar data, checked for military aircraft or transmitters in the area, and interviewed Bergstrom. No other aircraft were in the vicinity at the time. No military operations were active. The FAA issued a notice to airmen advising caution when flying over that section of Mount Rainier, though the notice did not specify the nature of the interference. In 1981, the National Park Service commissioned a study of the Emmons Glacier radio anomaly. A team from the USGS and the University of Washington conducted field tests over 2 weeks in August. They brought sophisticated radio equipment, GPS units, magnetometers, and ground-penetrating radar. The team was led by Dr. Yuki Delgado, a geophysicist specializing in electromagnetic phenomena. The team confirmed that radio communication failed within a defined area of the glacier. They mapped the boundary with GPS, establishing that the zone was approximately circular with a radius of 410 meters. Inside the zone, VHF radios, UHF radios, and even satellite phones could not transmit or receive. GPS devices continued functioning, though with slightly reduced accuracy. Magnetometers detected no anomalies. Ground-penetrating radar showed normal ice and bedrock structure. Dr. Delgado tested various hypotheses. Could the ice itself be blocking signals? Ice is generally transparent to radio waves. Could there be a subsurface metal deposit? The radar showed no such deposits. Could atmospheric conditions create a localized interference zone? Weather stations nearby recorded normal conditions. "We found nothing that would cause this," Delgado said in a 1983 paper published in the Journal of Geophysical Research. "The zone is real and reproducible. Any radio brought into that area stops working, but we cannot identify a source. There's no transmitter, no geological feature, no atmospheric condition that explains it." One detail troubled the research team: glaciers flow. The Emmons Glacier moves downslope at a rate of several feet per year. Objects on the glacier's surface migrate with the ice. Yet the radio dead zone had remained in the same position since at least 1962, nearly 20 years by the time of the study. The glacier should have carried any anomaly downslope, but the silence had not moved. Dr. Delgado's team placed permanent markers at the zone's boundary and measured the glacier's movement over 6 months. The ice flowed southwest at approximately 8 feet per year. The markers moved with it, but when they returned the following summer, the radio dead zone was still in the same location, now several feet behind where the markers had drifted. It's as if the zone is anchored to the ground beneath the ice, Delgado wrote. But the glacier is hundreds of feet thick there. Whatever is causing this would have to be deep in the bedrock, yet affecting the surface. The USGS report recommended continued monitoring but offered no conclusions. A copy was sent to the National Science Foundation, which declined to fund further research, citing insufficient theoretical basis for additional investigation. In 1992, a mountaineering guide named Priya Mbara was leading a client up the Emmons Glacier when her satellite phone newly available technology at the time failed inside the dead zone. Satellite phones operate on different frequencies than VHF radios and communicate with orbiting satellites rather than ground stations. They are designed to work in remote areas where terrestrial communication is impossible. Yet inside the zone, Mbara's satellite phone could not establish a connection. She reported the incident to the Park Service. A ranger tested a satellite phone in the zone in 1993 and confirmed the failure. The FAA was notified. They updated their advisories to include satellite communication disruption. By the early 2000s, GPS technology had become standard for backcountry navigation. Climbers entering the Emmons Dead Zone noticed that while their GPS units continued to function, they displayed reduced accuracy, position errors of up to 50 feet, compared to typical errors of less than 10 feet outside the zone. The GPS satellites themselves were unaffected. The issue was with signal reception at ground level. In 2005, a team of researchers from MIT requested permission to study the anomaly. They proposed using drones, equipped with radio transmitters and receivers, to map the dead zone from above. The Park Service approved the study. The drones flew over the area at various altitudes, transmitting continuously. At altitudes above 1,000 feet, transmissions were received normally. Below 1,000 feet, signals degraded. At the glacier's surface, communication ceased entirely. The MIT team's lead researcher, Dr. Helena Vukovic, described the results as consistent with a hemispherical interference zone centered on the glacier. She could not explain the source. It's not jamming in the traditional sense, she said. Jamming requires a transmitter producing noise or conflicting signals. We detected no such transmitter. The signals simply stop propagating. They vanish. The study was published in 2007. Peer reviewers questioned whether the phenomenon might be related to ionospheric disturbances or solar activity. Follow-up measurements during different solar cycles showed no correlation. The dead zone persisted regardless of space weather. Attempts to drill into the bedrock beneath the glacier to investigate possible subsurface causes were proposed in 2009, but never funded. The cost and logistical challenges of drilling through hundreds of feet of ice in a remote crevassed location were prohibitive. The Park Service maintains the Emmons Glacier Dead Zone in its internal database of unusual phenomena. Rangers briefing climbing teams mention it as a known communication issue. Guides mark it on their maps. The FAA continues to include it in advisories for low-altitude flights over Mount Rainier. In 2018, a journalist named Thomas Kowalski hiked onto the Emmons Glacier with a modern smartphone, a satellite messenger device, and a handheld GPS. Inside the dead zone, the phone showed no signal. The satellite messenger could not send messages, and the GPS displayed degraded accuracy. He stood in the center of the silence and tried to make a call. The phone showed full battery, full signal bars, but the call would not connect. It was as if the network had never existed. Kowalski wrote an article about the experience for a regional outdoor magazine. He noted that the dead zone had been documented for over 50 years and remained unexplained. Technology has changed, he wrote. Radios, satellite phones, GPS, smartphones all operate on different principles, use different frequencies, communicate through different systems, yet all fail in the same spot on the glacier. The common factor isn't the technology, it's the location. The Emmons Glacier continues to flow, carving its path down the mountain, reshaping itself with each season's snow and ice. And within that moving river of ice, a circle of silence remains fixed, immovable, waiting for anyone who steps inside to discover that their voice, no matter how loud, will not carry beyond the boundary. Some disasters cast shadows backward through time. Couts Creek drains the southwestern flank of Mount Rainier, flowing through a steep valley carved by glacial meltwater and periodic debris flows. The creek's watershed begins at the terminus of the Couts Glacier, more than 8,000 feet above sea level, and descends through dense forest to join the Nisqually River near the park's southwestern boundary. The terrain is unstable, loose volcanic soil, steep slopes, and heavy seasonal runoff create conditions favorable for lahars, the fast-moving mudflows that are among Mount Rainier's most dangerous hazards. Mount Rainier is considered one of the most hazardous volcanoes in the United States, not because of eruption risk, but because of its potential to generate catastrophic mudflows. The mountain's glaciers rest on layers of hydrothermally altered rock, weakened clay-rich material that becomes fluid when mixed with water. Even without an eruption, glacier outburst floods or heavy rainfall can trigger lahars that travel dozens of miles downstream, burying valleys under meters of mud and debris. On October 2, 1947, a portion of the Couts Glacier collapsed. The ice and rock avalanche melted rapidly as it descended, mixing with water and sediment to form a lahar. The mudflow traveled down Couts Creek at speeds estimated at 40 to 50 miles per hour, reaching the Nisqually River in less than 15 minutes. The flow destroyed a section of the Nisqually-Longmire Road, buried several hiking trails, and inundated a small campground near the creek's confluence with the river. 38 people were in the area at the time. All survived, though several were injured and had to be evacuated by park rangers. The 1947 Couts Creek Lahar was one of the most significant non-eruptive debris flows in Mount Rainier's recorded history. The USGS studied the event extensively, documenting the flow's volume, speed, and path. The disaster led to improved monitoring systems and evacuation protocols throughout the park. But there was another aspect of the event that was not included in official reports, something that emerged only in the months following the mudflow, when survivors began comparing their experiences. In March of 1948, a park ranger named Walter Desjardins was interviewing survivors as part of a routine follow-up assessment. He spoke with a woman named Helena Kowalski, who had been hiking near Couts Creek with her husband on the day of the mudflow. During the interview, Kowalski mentioned that she had been having recurring dreams about the event. Desjardins noted this as a normal stress response. Then Kowalski added something unusual. The dreams were not about the mudflow itself, but about standing in the creek bed hours before it happened, watching it approach. "I dream that I'm standing exactly where I was that afternoon," Kowalski said, according to Desjardins' notes. "But it's morning, maybe 10 a.m. The sun is different. And I can see the mudflow coming down the valley. I try to move, but I can't. I try to shout to warn people, but no sound comes out. I just stand there and watch it approach. Then I wake up." Desjardins filed the report and thought little of it. Trauma-related dreams were expected. But over the following weeks, he interviewed 11 other survivors. 6 of them reported similar dreams. The details varied slightly, but the core elements were consistent. They dreamed of being at Couts Creek in the morning, hours before the mud flow occurred, unable to move or speak, watching the disaster unfold in advance. A survivor named Marcus Vargas described his dreams as prophetic, but useless. He said, "I'm standing on the trail near the bridge. It's early, maybe 9 or 10 in the morning. I can hear the rumble coming from up the valley. I know what's about to happen. I know I need to leave, but my legs won't move. And when I try to call out, nothing happens. I'm stuck there, just watching." Another survivor, a man named Jamal Okafor, reported the same experience. "The dream is always the same," he said. "I'm at the campground. It's morning. I hear the sound like thunder, but constant. I see the trees shaking upstream. I know the mud flow is coming. I try to run, try to yell, but I can't. I'm frozen. I watch it get closer and closer. Then I wake up." Desjardins collected statements from all 6 survivors who reported the dreams. He noted that none of them had discussed their dreams with each other before his interviews. They lived in different towns, Seattle, Tacoma, Portland, and had no ongoing contact. Yet their descriptions were remarkably similar. Each placed themselves at Couts Creek in the morning. Each described an inability to move or speak. Each watched the mud flow approach. Each woke before it arrived. In April 1948, Desjardins shared his findings with the park's chief ranger, a woman named Amara Tanaka. Tanaka was skeptical, but agreed that the consistency was unusual. She suggested Desjardins contact a psychologist to determine whether the dreams represented a known trauma response. Desjardins reached out to Dr. Yuki Rousseau, a psychiatrist at the University of Washington who specialized in disaster-related psychological trauma. Rousseau reviewed the interviews and found the pattern intriguing. "Recurring dreams after trauma are common," she said in a 1949 paper. "But these dreams share specific elements that go beyond typical post-traumatic manifestations." The survivors describe precognitive awareness, experiencing the disaster before it happened, combined with paralysis and aphonia. This constellation of symptoms is not standard in trauma literature. Rousseau conducted follow-up interviews with the survivors in May 1948. All 6 still reported the dreams, occurring 2 to 3 times per week. Rousseau asked detailed questions about the dream content. She discovered something that troubled her. The survivors described details about the mud flow's path that they should not have known. Helena Kowalski, for instance, dreamed of standing near a specific bend in Couts Creek where the mud flow had eroded a section of trail. Kowalski had not been at that location on October 2nd. She had been downstream, near the campground. Yet in her dreams, she stood at the bend and watched the flow carve through the hillside. USGS surveys conducted after the disaster confirmed that the flow had indeed followed the path she described. Marcus Vargas dreamed of a large boulder being carried by the mud flow and coming to rest against a footbridge. The boulder existed. It was documented in post-event photographs. But Vargas had not seen the boulder in person. He had been evacuated before the area was reopened. Yet he described its size, shape, and position with accuracy. Dr. Rousseau wrote in her notes, "The dreams appear to contain information the survivors could not have possessed through normal sensory experience. This suggests either remarkable coincidence or a phenomenon I am not equipped to explain." The dreams continued for approximately 6 months, then gradually ceased. By October 1948, all 6 survivors reported that the dreams had stopped. Rousseau conducted final interviews in November. She asked each survivor if they had any theories about the dream's content. None did. Most were relieved the dreams had ended and preferred not to dwell on them. Rousseau's findings were never published in a peer-reviewed journal. She included a brief mention of the case in a 1949 book on disaster psychology, describing it as an unusual cluster of trauma-related dreams with shared symbolic elements. She did not discuss the precognitive details, later explaining in a private letter that she lacked a framework for interpreting that aspect of the data. The Couts Creek survivors moved on with their lives. Most never returned to Mount Rainier. The mudflow site was eventually cleared, trails were rebuilt, and the area returned to normal use. The 1947 Lahar became a case study in volcanic hazard management, cited in USGS reports and used to improve early warning systems. The dreams were forgotten. In 2010, a neurologist named Dr. Thomas Bergstrom began researching collective trauma responses in disaster survivors. Bergstrom specialized in studying how groups of people who experience the same traumatic event sometimes report shared psychological symptoms. He learned about the Couts Creek case while reviewing archived disaster psychology literature and became interested in tracking down surviving family members to see if any records or recollections remained. Bergstrom located 3 adult children of survivors, the son of Helena Kowalski, the daughter of Marcus Vargas, and the niece of Jamal Okafor. He interviewed them in 2011 and 2012. All 3 recalled their parents or relatives mentioning strange dreams after the mudflow. The son of Helena Kowalski had a box of his mother's personal papers, including a diary she kept in 1948. In the diary, Kowalski had written detailed accounts of her dreams. She described standing in the creek bed on the morning of October 2nd, watching the mudflow approach. She noted specific landmarks, trees, boulders, sections of trail, and described the flow's behavior as it moved through the valley. Bergstrom compared her descriptions to USGS reports from the disaster. The correspondence was exact. Kowalski had described, in dreams, events that occurred hours before she arrived at Couts Creek that afternoon. Bergstrom expanded his research. He obtained copies of Walter Desjardins' original interview notes from the National Park Service archives. He cross-referenced the survivors' dream descriptions with geological surveys and photographs taken after the mudflow. In every case where survivors described specific details, those details matched the physical evidence. The survivors dreamed of events they had not witnessed. Bergstrom wrote in a 2013 paper published in the Journal of Trauma Psychology. They described the mudflow's path, its timing, and its effects with accuracy that cannot be explained by post-event knowledge. They had not seen the damage before the dreams began. They had not read reports or viewed photographs. Yet their dreams contained precise information. Bergstrom proposed several hypotheses. Perhaps the survivors had unconsciously absorbed details from conversations with rescue workers or park rangers. Perhaps they had read newspaper accounts that included more information than they consciously remembered. But he acknowledged these explanations were insufficient. The level of detail, he wrote, and the consistency across multiple individuals suggests something more complex. I do not have an adequate explanation. The paper received little attention. Reviewers questioned the reliability of decades-old interview notes and second-hand recollections from family members. Bergstrom defended his methodology, but did not pursue the topic further. He moved on to other research. In 2016, a journalist named Priya Mbara read Bergstrom's paper and visited the Couts Creek area. She hiked the trails, examined the creek bed, and spoke with park rangers about the 1947 mudflow. She wrote an article for a regional magazine describing the disaster and the strange aftermath of shared dreams. The article included a quote from Bergstrom: "Trauma affects the brain in ways we're only beginning to understand. But this case suggests that groups of people under extreme stress might access information in ways that don't fit our current models of perception and memory." The article prompted a handful of responses from readers. One letter, from a woman who identified herself as the granddaughter of a Couts Creek survivor, stated, "My grandmother never talked about the mudflow. But my mother told me that for months afterward, my grandmother would wake up at night crying, saying she had been there in the morning and couldn't warn anyone. She said it was like she'd lived through it twice, once in a dream and once in reality." The Couts Creek Valley is quiet now. The creek flows clear in summer, milky gray in winter, when glacier melt runs high. Hikers walk the trails, pausing to read interpretive signs about the 1947 disaster. The mudflow's path is still visible in places: scarred hillsides, scattered boulders, sections of forest younger than the surrounding trees. And somewhere, in the archived notes of a park ranger, in the diary of a survivor, in the half-remembered stories passed down through families, there remains the image of people standing frozen in a dream, watching a disaster approach that had not yet occurred, unable to speak or move or change what was already written in the earth. North is not always where it should be. The Tahoma Woods occupy the western slope of Mount Rainier, between 3,000 and 4,500 feet in elevation, a dense corridor of old-growth Douglas fir, western red cedar, and western hemlock. The forest receives over 100 inches of precipitation annually, creating a perpetually damp understory, thick with ferns, moss, and decaying logs. Trails through the woods are few and poorly maintained. The terrain is steep, crossed by seasonal streams that carve gullies into the volcanic soil. Visibility is limited 50 feet on clear days, less in fog. The area was logged selectively in the early 1900s, before Mount Rainier became a national park in 1899. Some sections were spared due to difficult access and unstable slopes. By the 1920s, the Tahoma Woods had been largely left to regenerate, visited occasionally by surveyors mapping park boundaries and foresters assessing timber resources. The woods were never a popular destination. No scenic vistas, no alpine meadows, no glaciers, just dense, silent forest. In August of 1924, a survey team from the United States Geological Survey was conducting a boundary survey along the park's western edge. The team leader, a man named Edwin Delgado, was responsible for establishing precise coordinates using compass bearings and theodolite measurements. On August 17th, while working in the Tahoma Woods near the South Puyallup River, Delgado noticed that his compass was reading incorrectly. Delgado had been a surveyor for 12 years. He knew his equipment. A magnetic compass, when properly calibrated and free from local interference, should point toward magnetic north, a direction that varies slightly from true north, depending on location and year, but is predictable and mappable. In western Washington in 1924, magnetic declination was approximately 22 degrees east of true north. Delgado's compass should have reflected this. Instead, it pointed roughly 25 degrees west of true north, a deviation of 47 degrees from where it should have been. Delgado assumed his compass had been damaged or magnetized by contact with metal equipment. He retrieved a backup compass from his pack. It showed the same deviation. He asked his assistant, a younger surveyor named Helena Kowalski, to check her compass. Hers also pointed west by the same amount. They moved 100 feet upslope. The deviation remained. They moved downslope. Still the same. Delgado marked the location and continued the survey, noting the anomaly in his field book. Over the next 3 days, the team mapped the extent of the deviation. They found it covered an irregular area, roughly 3 miles across, bounded approximately by the South Puyallup River to the south, Tahoma Creek to the north, and elevation contours on either side. Within this area, every compass pointed 47 degrees west of true north. Outside the area, compasses functioned normally. Delgado reported the findings to the USGS office in Tacoma. His supervisor, a geologist named Marcus Vargas, reviewed the field notes and was skeptical. Magnetic anomalies do occur, usually caused by iron-rich rock, buried metal deposits, or localized geological structures, but they are rarely uniform over large areas. Vargas requested that Delgado return to the site with magnetometers to measure the Earth's magnetic field directly. In September 1924, Delgado and a geophysicist named Dr. Amara Okafor conducted a detailed survey of the Tahoma Woods. They carried two magnetometers instruments that measure the strength and direction of magnetic fields. Inside the anomalous area, the magnetometers detected no unusual magnetic field strength. The Earth's magnetic field appeared normal in intensity, yet compasses still deviated by 47 degrees. "This doesn't make sense," Okafor wrote in her report. "A compass deviation of this magnitude should be accompanied by a measurable change in the magnetic field. We detect no such change. The field strength is consistent with regional values, yet the compasses all point in the wrong direction." The team expanded their measurements. They established a grid of survey points across the woods, measuring compass bearings and magnetic field strength at each location. The deviation was remarkably consistent always, 47 degrees, regardless of position within the zone, and the boundary was sharp. Standing just outside the affected area, a compass would point correctly. Taking 2 steps into the woods, the needle would swing 47 degrees west. Taking 2 steps back out, it would return to normal. Dr. Okafor examined the geology. The Tahoma Woods sit on layers of volcanic ash and lahar deposits from past eruptions of Mount Rainier. Core samples taken from the area showed typical volcanic material: andesite, ash, clay. No unusual concentrations of magnetic minerals. No buried metal. Nothing that would explain the compass behavior. The USGS published a technical bulletin in 1925, documenting the anomaly. The bulletin included maps showing the extent of the deviation zone and tables of magnetic field measurements. The conclusion was tentative. A localized compass deviation of unknown origin has been identified in the Tahoma Woods area of Mount Rainier National Park. The deviation does not correlate with detectable magnetic field anomalies. Further investigation is recommended. The anomaly became a minor curiosity among surveyors and park rangers. Those working in the area learned to compensate using celestial navigation or landmarks rather than compasses. The Park Service installed trail markers to help hikers avoid getting disoriented, but the woods remained little visited. The deviation zone was not publicized beyond technical circles. In 1953, a park ranger named Jamal Rousseau was conducting a wildlife survey in the Tahoma Woods. He carried a standard magnetic compass and a map. As he moved through the forest, he noticed his compass readings did not match his expected position. Familiar with the deviation, he attempted to compensate, but found himself increasingly disoriented. After 3 hours of attempting to navigate, he realized he had been walking in a large circle. He eventually found his way out by following a stream downslope. Rousseau reported the experience in his logbook, noting, "The compass deviation in Tahoma Woods is more disorienting than expected. Even with knowledge of the anomaly, navigation is difficult. The uniform nature of the forest, no landmarks, limited visibility combined with false compass readings, creates profound directional confusion." Several hikers in the 1960s and 70s reported becoming lost in the Tahoma Woods, despite carrying compasses and maps. Most were found within a day, having wandered in circles or ended up miles from their intended destinations. The Park Service began discouraging travel in the area, designating it as unsuitable for recreational use. In 1982, Dr. Yuki Tanaka, a geophysicist from the University of Washington, received a grant to study magnetic anomalies in the Pacific Northwest. She learned of the Tahoma Woods deviation and requested access to conduct a comprehensive survey. The Park Service approved, and Tanaka spent 2 weeks in the woods in September 1982. Tanaka brought modern equipment, digital magnetometers, portable computers, and GPS units. GPS technology was new in the early 80s, available primarily to military and research institutions. Tanaka used it to establish precise positions, independent of compass navigation. Her measurements confirmed what had been documented nearly 60 years earlier: compass deviation of 47 degrees. No corresponding magnetic field anomaly. Sharp boundary. Tanaka also tested electronic compasses devices that use solid-state sensors rather than magnetized needles. These compasses also deviated by 47 degrees within the zone. This rules out mechanical issues with traditional compasses, Tanaka wrote in her 1983 report. Electronic sensors are responding to the same phenomenon. Whatever is causing this affects the perception or measurement of magnetic north, not just the behavior of magnetized metal. Tanaka's report was published in the Journal of Geophysical Research. It received moderate attention within the geophysics community. Several researchers proposed hypotheses: subsurface metal deposits that somehow altered the field without increasing its strength, ionospheric disturbances affecting compass readings, or measurement error. Each hypothesis was examined and found lacking. Tanaka concluded, the Tahoma Woods compass deviation remains unexplained. Standard geophysical models do not account for the observed behavior. In 1995, the USGS conducted a follow-up survey using satellite magnetometry measurements taken from aircraft and satellites to map the Earth's magnetic field over large areas. The data showed no anomaly over the Tahoma Woods. The magnetic field, as measured from above, was uniform across the region, yet ground-based compasses still deviated. It's as if the anomaly only exists at ground level, said Dr. Thomas Bergstrom, the USGS geophysicist who analyzed the satellite data. From above, everything looks normal. But stand in the woods, and your compass points the wrong way. I've never seen anything like it. In 2003, a hiker named Priyam Bara entered the Tahoma Woods with a modern smartphone, equipped with a digital compass and GPS. Inside the deviation zone, her phone's compass displayed incorrect readings, 47 degrees west of true north. The GPS, however, functioned normally, showing her position accurately. She documented the experience with photographs and videos, which she posted online. The post attracted some attention, but was largely dismissed as a malfunction or hoax. In 2009, a team of researchers from MIT requested permission to install permanent monitoring equipment in the Tahoma Woods. They proposed using an array of magnetometers, GPS receivers, and environmental sensors to collect long-term data on the anomaly. The Park Service denied the request, citing concerns about environmental impact and the area's designation as minimal-use wilderness. The decision frustrated researchers. Dr. Helena Vukovic, who had led the MIT proposal, wrote in a 2010 editorial, "The Tahoma Woods anomaly represents a genuine scientific mystery. We have documented evidence spanning nearly a century. Yet institutional resistance to further study effectively ensures the phenomenon will remain unexplained." In 2015, a journalist named Marcus Desjardins hiked into the Tahoma Woods with a film crew to document the deviation. They carried multiple compasses, magnetic, electronic, and smartphone-based. All showed the 47-degree deviation within the zone. Desjardins interviewed park rangers and reviewed historical records. His resulting documentary aired on a regional cable channel and briefly increased public awareness of the anomaly. One ranger, a woman named Nadia Ilunga, who had worked at Mount Rainier for 18 years, described her perspective. "I've been in those woods dozens of times. You get used to the compass being wrong, but it never stops feeling strange. It's not just the needle pointing the wrong way, it's that the boundary is so precise. One step you're fine, next step your compass is lying to you. And it's been doing that for 100 years. The Park Service maintains a notice about the deviation on its website, buried in a section on navigational hazards. The notice advises hikers to use GPS rather than compasses in the Tahoma Woods, and recommends staying on marked trails. Few people visit the area. The woods remain quiet, dense, and perpetually damp. In 2021, a physics graduate student named Jamal Kowalski wrote his dissertation on unexplained geophysical phenomena. He included a chapter on the Tahoma Woods, reviewing all available literature and proposing several speculative theories involving localized distortions in the geomagnetic field caused by deep crustal structures. His advisor noted that while the theories were creative, they lacked testable predictions and supporting evidence. The Tahoma Woods compass deviation remains on record documented, reproducible, and entirely unexplained. Compasses still point 47 degrees west of true north, within a 3-square-mile area of forest. The boundary remains sharp. The deviation remains constant. And somewhere in a filing cabinet at the USGS office in Tacoma, Edwin Delgado's 1924 field notes sit alongside modern reports, all describing the same impossible phenomenon. A place where north is not where it should be, and has not been for over a century. Flowers do not remember the dead, except when they do. Berkeley Park sits at 5,700 feet on the northeast shoulder of Mount Rainier, a subalpine meadow system accessible via the Northern Loop Trail. The park, named not for the California city, but for an early surveyor, spans roughly 200 acres of rolling terrain, dotted with tarns, punctuated by stands of subalpine fir, and carpeted in summer with wildflowers. Lupine, paintbrush, phlox, and avalanche lilies bloom in waves from late June through August, drawing hikers and photographers to witness one of the mountain's most vibrant displays. The area is remote. The nearest road ends at sunrise, 4 miles away by trail. Berkeley Park sees moderate foot traffic during summer weekends, but remains quiet most days. The meadows are fragile, and the Park Service restricts off-trail travel to prevent vegetation damage. Campsites are designated and limited. The landscape feels untouched, wild, and open beneath the mountain's northern face. Mount Rainier has a history of aviation incidents. The mountain's size, weather, and glaciated terrain make it a hazard to aircraft. Between 1940 and 1980, at least 10 planes crashed on or near the mountain. Some wrecks were recovered. Others remain entombed in glacial ice. One of these crashes occurred on December 18, 1944, when a B-17 bomber struck the South Tahoma Glacier during a training flight. The aircraft was carrying 9 crew members. None survived. The wreckage was buried under snow and ice and was not located until decades later. In July of 1968, a park botanist named Dr. Walter Okafor was conducting a vegetation survey in Berkeley Park. Okafor had been studying Mount Rainier's alpine flora for 6 years, documenting species distribution, bloom timing, and ecological interactions. On July 12, while photographing wildflowers near a small tarn in the park's eastern section, he noticed an unusual arrangement of lupine plants. The lupine's tall, purple-flowered perennials were blooming in a pattern that did not appear random. Okafor, trained to observe plant distribution, recognized geometric structure. The flowers formed a configuration of 7 distinct clusters, each containing multiple plants, arranged in a way that suggested intentionality. He photographed the pattern and noted it in his field journal, assuming it was a coincidence of seed dispersal or soil conditions. When he returned to his office at the University of Washington 2 weeks later, Okafor developed his photographs and studied the flower arrangement. Something about the pattern was familiar. He compared it to various geometric shapes and eventually realized it resembled a constellation. Specifically, it matched Orion's 7 prominent clusters corresponding to the constellation's main stars: Betelgeuse, Rigel, Bellatrix, Siph, and the 3 stars of Orion's belt. Okafor was skeptical. Constellations are 2-dimensional projections of stars at vastly different distances. The odds of wildflowers naturally forming such a pattern seemed astronomical. He consulted with a colleague, an astronomer named Dr. Helena Vargas. Vargas examined the photographs and confirmed the match. "It's Orion," she said. "The spacing, the angles, it's accurate to within a few degrees." Okafor returned to Berkeley Park in July of 1969. The lupines bloomed again in the same location. The Orion pattern was present, identical to the previous year. He measured the distances between clusters, noted the number of plants in each cluster, and compared the arrangement to star charts. The pattern matched Orion as it appeared in the winter sky, not the summer sky when the flowers bloomed. This suggested the flowers were replicating a specific moment in time when Orion held a particular position. Vargas calculated that the pattern most closely matched Orion's appearance in mid-December, not July. Okafor found this detail troubling. Why would summer wildflowers bloom in a pattern reflecting winter stars? Over the next 5 years, Okafor monitored the Berkeley Park lupines annually. The pattern persisted. Each July, the same clusters bloomed in the same Orion configuration. In 1973, Okafor invited a colleague, a botanist named Dr. Amara Tanaka, to examine the site. Tanaka brought time-lapse photography equipment and set up cameras to record the flowers over several days. The footage revealed something unexpected. The flowers did not remain static. Individual plants within each cluster moved subtly, over the course of hours adjusting their positions. By morning, the Orion pattern was restored if any deviation had occurred overnight. Plants that had leaned or shifted due to wind or gravity corrected their orientation, returning to their designated positions within the constellation. Plants move in response to light, gravity, and growth, Tanaka said in a 1974 interview. Heliotropism, gravitropism, these are well documented. But coordinated movement to maintain a geometric pattern? That's not in the botanical literature. Tanaka's time-lapse videos showed lupine stems bending, flowers rotating, and leaves adjusting in ways that suggested purposeful repositioning. The movements were slow millimeters per hour, but consistent. Over a 12-hour period, a plant that had been displaced would return to its proper position within the pattern. In 1975, Okafor and Tanaka published a paper in the Journal of Mountain Ecology describing the Berkeley Park lupine pattern. The paper included photographs, measurements, and time-lapse footage. The authors were cautious in their conclusions. We have documented a recurring spatial arrangement of Lupinus latifolius in Berkeley Park that corresponds to the constellation Orion. The mechanism by which this arrangement is maintained is unknown. Further study is required. The paper attracted attention from botanists and ecologists. Some suggested the pattern was the result of selective herbivory animals grazing certain plants and not others, creating the appearance of intentional arrangement. Others proposed that soil chemistry or microtopography created conditions favorable for lupines in those specific locations. Both hypotheses were tested and found insufficient. Herbivory was random in the area, and soil samples showed no unusual variation. In 1977, a graduate student named Marcus Rousseau, working under Tanaka's supervision, conducted a detailed study of the lupines. He excavated root systems, analyzed genetic samples, and measured plant spacing with precision instruments. His findings, completed in 1978, noted that the lupines in the Orion pattern were genetically indistinguishable from lupines elsewhere in Berkeley Park. There was no unique subspecies, no anomalous physiology. The plants were normal in every measurable way except their behavior. Rousseau also discovered something unusual in the park's historical records. In 1945, a Park Service ranger had filed a report mentioning wildflowers in Berkeley Park that bloomed in strange shapes. The report was brief and nonspecific, but the date was notable: July 1945, 7 months after the B-17 crash. Okafor requested access to military records related to the December 1944 crash. The Air Force provided limited documentation. The bomber had been on a training mission from Moses Lake, Washington, to Portland, Oregon. Weather conditions were poor, heavy cloud cover, snow, low visibility. The aircraft deviated from its flight path and struck the mountain. Search efforts in 1945 were unsuccessful. The wreckage was not located at that time. In 1947, climbers discovered debris from the B-17 on the South Tahoma Glacier, approximately 8 miles southwest of Berkeley Park. The Air Force recovered some remains and wreckage, but left much of the material in place, as extraction from the glacier was deemed too hazardous. The crash site is now considered a grave, and disturbance is prohibited. Okafor wondered if there could be a connection between the crash and the flower pattern. Dr. Vargas, the astronomer, calculated the position of Orion on the night of December 18, 1944. The constellation's configuration matched the lupine arrangement almost exactly. Orion had been visible in the southern sky around 8 p.m. Pacific time, on that date approximately when the bomber was believed to have crashed. The connection was suggestive but unexplained. How could wildflowers in Berkeley Park, miles from the crash site, reflect a constellation visible on a specific night decades earlier? Okafor had no hypothesis. He noted the correlation in his research files, but did not publish it. "I don't deal in symbolism," he said in a 1980 interview. "I study plants, but this pattern exists, and I can't explain it." In 1983, the Park Service asked Okafor to brief park rangers on the Berkeley Park flowers. Some rangers had noticed the pattern independently and wondered if it had cultural or historical significance. Okafor explained his findings and the possible link to the B-17 crash. One ranger, a woman named Priya Desjardins, mentioned that hikers occasionally left flowers or small memorials near the lupine patch, though she did not know why. In 1992, a botanist from Oregon State University named Dr. Yuki Bergstrom attempted to disrupt the lupine pattern. She carefully transplanted several lupines from within the Orion configuration to locations outside the pattern. She marked their original positions and monitored them over the summer. By mid-July, the transplanted lupines had died. New lupines sprouted in the original positions, restoring the pattern. Bergstrom's experiment was controversial. The Park Service reprimanded her for damaging vegetation in a protected area. Her findings were documented in a technical report, but not published in a peer-reviewed journal. She noted, "The pattern self-corrects. Remove plants, and they are replaced. The configuration persists despite interference." In 2003, a filmmaker named Thomas Mbara produced a short documentary about the Berkeley Park flowers. The film included interviews with Okafor, Tanaka, and family members of the B-17 crew. One family member, the nephew of a crew member named Lieutenant James Callahan, visited Berkeley Park and saw the lupines. He was moved by the pattern. "My uncle loved astronomy," he said. "Orion was his favorite constellation. To think that something here remembers him or remembers that night, it's more than I expected to find." The documentary aired on regional public television and generated brief public interest. Some viewers dismissed the pattern as coincidence. Others found it inexplicable and unsettling. In 2011, a team of botanists from the University of British Columbia installed motion-sensitive cameras around the lupine patch to capture the flower's nocturnal movements. The footage confirmed what Tanaka had documented decades earlier. The plants adjusted their positions overnight, maintaining the Orion configuration. Time-lapse sequences showed stems bending, flowers rotating, and clusters realigning in coordinated motion. The lead researcher, Dr. Nadia Kowalski, analyzed the footage frame by frame. "The movements are not random," she said in a 2012 interview. "There's synchronization. Plants across the pattern move in ways that suggest communication or shared response to a stimulus we can't detect." Kowalski proposed that the plants might be responding to subsurface water flow, magnetic fields, or root interactions that create coordinated behavior. She tested each hypothesis. Water flow patterns did not correlate with plant movement. Magnetic field measurements showed no anomalies. Root excavation revealed normal lupine root systems with no unusual connections. The Berkeley Park lupines continue to bloom each July. The Orion pattern persists. Park rangers mention it occasionally to hikers who ask about the wildflowers. Most visitors do not notice the arrangement unless it is pointed out. Once seen, it is difficult to unsee. Dr. Walter Okafor retired in 2015. In his final interview before retirement, he was asked if he had any theories about the flowers. He paused for a long time before answering. "I've spent 50 years studying plants," he said. "I know how they grow, how they respond to their environment, how they reproduce. But I don't know why those lupines form that pattern, or how they maintain it, or what it means. If it means anything, I've accepted that I won't have an answer before I die." The 9 crew members of the B-17 bomber remain on the South Tahoma Glacier, entombed in ice. The wreckage shifts slowly downslope, buried deeper each year under accumulating snow. And 8 miles away, in a meadow where summer light fills the air with the scent of alpine flowers, lupines bloom in the shape of stars that shone on a winter night when 9 men fell from the sky and never came home. Distance and time should correspond, except when they refuse to. The Wonderland Trail encircles Mount Rainier, a 93-mile loop that traverses alpine meadows, glacial valleys, and old-growth forest. Completed in 1915, the trail crosses streams, climbs ridges, and passes through some of the most remote terrain in the national park. Most hikers complete the circuit in 10 to 14 days, camping at designated sites and resupplying at ranger stations. The trail is well maintained, clearly marked, and heavily documented. Guidebooks provide detailed mileage, elevation profiles, and estimated hiking times for each section. The segment between Indian Bar and Summerland is considered moderate in difficulty. It begins at Indian Bar, a high camp at 5,600 feet, and climbs gradually through subalpine meadows before descending slightly to Summerland, another camp at 5,900 feet. The trail follows Frying Pan Creek for part of the distance, crosses talus slopes, and passes through stands of mountain hemlock. The terrain is open, with good visibility. The trail is well graded, with no technical obstacles. According to park maps, the distance is 1.7 miles. Average hiking time, based on standard calculations, should be 30 to 40 minutes depending on pace. But hikers consistently report that this section takes 47 minutes. Not approximately 47 minutes, exactly 47 minutes. In August of 1998, a hiker named Marcus Delgado completed the Wonderland Trail and noticed something unusual while reviewing his trip logs. Delgado was a meticulous planner. He carried a GPS unit, a wristwatch, and a detailed trail guide. He recorded his start and stop times for each trail section, comparing his actual pace to guidebook estimates. For most sections, his times matched expectations slightly faster or slower, depending on terrain and fatigue. But the Indian Bar to Summerland section stood out. Delgado had started from Indian Bar at 9:15 a.m. He reached Summerland at 10:02 a.m., 47 minutes. His guidebook estimated 35 minutes. He assumed he had hiked slowly, perhaps distracted by scenery or stopping to rest. But his GPS log showed he had covered the distance at his normal pace, approximately 2 miles per hour, consistent with his average throughout the trip. The mileage was correct. The pace was normal, but the time was wrong. Delgado mentioned this discrepancy in an online trip report. Several other hikers responded, noting similar experiences. One hiker, a woman named Helena Vargas, said she had completed the same section in 1996 and also recorded 47 minutes, despite hiking faster than usual. Another hiker, a man named Thomas Okafor, reported 47 minutes in 1997. He had specifically timed the section because he was training for ultramarathons and tracked his splits carefully. In 1999, a park ranger named Jamal Rousseau read the online discussion and became curious. Rousseau had hiked the Wonderland Trail multiple times and was familiar with the Indian Bar to Summerland section. he decided to test the phenomenon himself. On a clear day in July, he hiked from Indian Bar to Summerland, timing himself with 2 watches, one digital, one analog, and a GPS unit. He hiked at a brisk pace, faster than most recreational hikers. He covered the 1.7 miles in what felt like 25 or 30 minutes. When he checked his watches, both showed 47 minutes had elapsed. Rousseau was puzzled. He reviewed his GPS log. The device had recorded his position at regular intervals. The distance was accurate, 1.7 miles. His speed had averaged approximately 4 miles per hour, which should have resulted in a time of roughly 25 minutes. But his watches disagreed. 47 minutes. Rousseau discussed the discrepancy with a colleague, a ranger named Dr. Amara Tanaka, who had a background in geography and cartography. Tanaka suggested that the trail's measured distance might be incorrect, or that GPS accuracy in the area was compromised by terrain or satellite geometry. Rousseau returned to the section with Tanaka in August. They measured the trail using a surveyor's wheel, GPS waypoints, and pacing. The distance was confirmed at 1.7 miles. GPS accuracy was normal, within 10 feet. Yet when they hiked the section, their watches again recorded 47 minutes, despite covering the distance in what subjectively felt like half that time. In 2000, Tanaka began collecting data from other hikers. She posted notices at Indian Bar and Summerland campsites, asking hikers to record their start and stop times for the section and to note their watch type and hiking pace. Over the summer, she received reports from 32 hikers. 30 reported completing the section in 47 minutes. 2 reported 46 minutes and 48 minutes, which Tanaka attributed to rounding or delayed watch checking. The consistency troubled her. Hiking times vary widely depending on fitness, pack weight, trail conditions, and weather. Yet this section produced nearly identical times across a diverse population of hikers, experienced backpackers, casual day hikers, ultralight enthusiasts, families with children. All recorded 47 minutes. One hiker, a software engineer named Priya Bergstrom, carried a fitness tracker that recorded her pace continuously. Her data showed she had hiked at 2.3 miles per hour, her average speed for the entire Wonderland loop. At that pace, 1.7 miles should have taken 44 minutes. Her tracker recorded 44 minutes. Her wristwatch recorded 47 minutes. Bergstrom's observation suggested a discrepancy between real-time tracking and elapsed time measurement. GPS devices and fitness trackers calculated time based on distance covered and speed. Watches measured time directly. The two methods were producing different results. In 2002, Tanaka contacted Dr. Yuki Desjardins, a physicist at the University of Washington. Desjardins specialized in time measurement and GPS technology. Tanaka explained the phenomenon and provided the collected data. Desjardins was skeptical but agreed to investigate. In July 2003, Desjardins hiked the Indian Bar to Summerland section with Tanaka. They carried multiple timing devices, atomic synchronized watches, GPS units, smartphones, and a portable cesium clock, a highly accurate timekeeping device used in scientific research. They started from Indian Bar at precisely 1100 hours, according to the cesium clock. They hiked at a measured pace, stopping at intervals to check their devices. They reached Summerland at 11:47 hours, 47 minutes later according to all watches and the cesium clock. But the GPS log showed they had covered the distance in approximately 30 minutes of actual movement, accounting for brief stops. Desjardins examined the GPS data closely. The device had recorded timestamps for each waypoint. The intervals between waypoints matched what would be expected for their hiking speed. But when the total elapsed time was calculated from the start and end timestamps, the result was 47 minutes. The GPS clock, synchronized to satellite time, agreed with the wristwatches and the cesium clock. This doesn't make sense, Desjardins said in a 2004 interview. GPS time is derived from atomic clocks on satellites. It's extraordinarily accurate. If the GPS says 47 minutes passed, then 47 minutes passed. But the distance and speed data suggest less time should have elapsed. One of these measurements is wrong, but I can't determine which. Desjardins returned to the trail multiple times over the next 2 years, conducting experiments with different equipment and methodologies. He synchronized multiple clocks before entering the section, then compared them afterward. All remained synchronized. He measured the trail distance with high-precision GPS equipment. The distance was correct. He reviewed satellite data to check for GPS errors or anomalies. None were found. In 2006, Desjardins published a brief article in a physics journal describing the phenomenon. The article was titled, "Temporal Anomaly on the Wonderland Trail: Inconsistent Measurements of Hiking Duration." The paper presented the data without offering an explanation. Peer reviewers were divided. Some suggested measurement error or statistical coincidence. Others acknowledged the phenomenon was unusual, but noted that further investigation would require resources and expertise beyond Desjardins' capacity. The article attracted limited attention within academic circles. A few physicists proposed hypotheses: localized gravitational anomalies affecting timekeeping devices, atmospheric conditions interfering with GPS signals, or psychological factors causing hikers to misjudge elapsed time. Each hypothesis was examined and found lacking. Gravitational effects strong enough to cause measurable time dilation would be detectable by other means and would affect the entire region, not a specific trail section. GPS interference would produce position errors, not time discrepancies. Psychological misjudgment could not explain synchronized clock readings. In 2009, the Park Service was asked by a journalist whether they had investigated the time anomaly. A spokesperson stated that the Park Service was aware of anecdotal reports, but had not conducted an official study. Trail distances and conditions were regularly monitored, and no irregularities had been identified. The spokesperson added that hikers should trust their GPS devices for navigation and not rely solely on time estimates. The response frustrated researchers. Dr. Tanaka, who had collected much of the original data, wrote a letter to the Park Service requesting that permanent timing stations be installed at Indian Bar and Summerland to record hikers' passage. The request was denied due to budget constraints and concerns about infrastructure in wilderness areas. In 2012, a group of hikers decided to test the phenomenon as a group. 8 individuals started from Indian Bar simultaneously, hiking at different paces. The fastest hiker, a trail runner named Nadia Mbara, covered the section in what subjectively felt like 15 minutes. The slowest, an older hiker named Walter Kowalski, took what felt like an hour. When they compared watches at Summerland, all 8 had recorded 47 minutes. Their GPS devices showed varying speeds and movement times, but their watches agreed 47 minutes had passed. Mbara described the experience as disorienting. "I felt like I was moving quickly," she said. "I was almost jogging, but when I looked at my watch, nearly 50 minutes had gone by. It didn't match my perception at all." Kowalski had the opposite experience. "I was moving slowly, taking my time," he said. "I expected it to take over an hour, but my watch said 47 minutes. It felt wrong." In 2015, a documentary filmmaker named Thomas Vukovic hiked the Wonderland Trail and included footage of the Indian Bar to Summerland section in his film. He wore a GoPro camera recording continuously. The footage showed him hiking at a normal pace, covering the trail in what appeared to be approximately 30 minutes of real time. But when he checked the video file's metadata and compared it to his watch, 47 minutes had elapsed. Vukovic showed the footage to a video editor who examined the file frame by frame. The video played at normal speed. There were no skipped frames, no gaps, no evidence of tampering. The footage duration was 31 minutes. but the timestamp gap between the start and end of the hike was 47 minutes. I don't know how to explain it, Vukovic said in his film. The video shows one thing, the clocks show another. Both can't be right. But I've checked everything. I can't find an error. The Wonderland Trail remains one of the most popular long-distance hikes in the Pacific Northwest. Thousands of people complete it each year. Most never notice the time anomaly on the Indian Bar to Summerland section. Those who do often dismiss it as a mistake or a quirk of their devices. But the pattern persists. Hikers who time themselves carefully, who compare watches and GPS logs, who check and recheck their data, they all report the same result. 47 minutes. Always 47 minutes. Dr. Yuki Desjardins, the physicist who spent years studying the phenomenon, retired in 2020. In a final interview, he was asked if he had ever reached a conclusion. He paused before answering. "I know how to measure time," he said. "I've spent my career doing it. But that trail section breaks every rule I understand. Time passes, distance is covered, and the two don't match. I can document it, I can repeat it, but I can't explain it. And that bothers me more than I can say." The trail between Indian Bar and Summerland remains unchanged. Hikers walk it every summer, crossing meadows and talus slopes, following Frying Pan Creek, breathing the thin mountain air. And somewhere in that 1.7 miles, time bends in a way that watches can measure, but minds cannot comprehend. 47 minutes, carved into the fabric of every journey, waiting for anyone who checks their watch at Summerland and wonders why the numbers feel wrong. Numbers should add up, except when someone decides they should not. White River Campground sits at 4,200 feet on the northeast side of Mount Rainier, adjacent to the White River entrance to the national park. Established in the 1930s, the campground consists of 112 sites, spread across a forested area near the confluence of the White River and Frying Pan Creek. The sites are designed for tents and small recreational vehicles. The campground operates on a first-come, first-served basis during summer months, typically filling by early afternoon on weekends and holidays. A ranger station at the entrance monitors arriving vehicles and collects fees. The White River area has long served as a gateway to Mount Rainier's northern climbing routes. Sunrise Road, which branches from the campground access road, leads to the Sunrise Visitor Center, the highest point in the park, accessible by vehicle. The campground itself is surrounded by old-growth forest, with trails leading to Glacier Basin, Emmons Moraine, and the Interfork. The terrain is steep, the forest dense. Cell phone coverage is non-existent. Radio communication with park headquarters at Longmire is sporadic. Mount Rainier National Park maintains detailed records of visitor numbers, camping permits, and vehicle entries. These records serve administrative, safety, and resource management purposes. Each campground has protocols for counting overnight guests. Rangers conduct evening patrols, noting which sites are occupied and estimating the number of people per site. Entrance stations record vehicle counts using mechanical or electronic counters. The data is compiled daily and submitted to park administration. On the evening of August 4th, 1989, Ranger Marcus Okafor completed his patrol of White River Campground. Okafor had worked at Mount Rainier for 7 years and was familiar with the routine. He walked the campground loop roads, noting which sites were occupied, which were empty, and whether any violations or safety concerns existed. He recorded his observations on a standardized form. According to Okafor's patrol report, 18 sites were occupied that evening. He estimated a total of 43 people, families, couples, a few solo campers. The campground was quieter than usual for early August. Weather had been unsettled, rain in the afternoon, clouds obscuring the mountain. Many visitors had likely chosen to stay at lower elevations or postpone their trips. The entrance station at White River recorded 71 vehicles entering the park on August 4th. This number included day visitors, climbers accessing trailheads, and campers. The fee collection log noted 32 camping registrations, individual parties who paid the overnight fee and received camping permits. Not all parties arrived in separate vehicles. Families and groups often carpooled. On August 6th, Okafor submitted his patrol reports to the park's administrative office at Longmire. The reports were routine paperwork compiled with data from other campgrounds, entrance stations, and visitor centers to produce weekly and monthly summaries of park usage. Okafor did not expect any issues. The numbers were typical for a weeknight in early August. On August 10th, Okafor received a call from the park's chief of administration, a woman named Dr. Helena Vargas. Vargas asked Okafor to clarify his August 4th patrol report. Specifically, she wanted to know if he had made an error in his occupancy count. Okafor reviewed his notes. He had recorded 18 occupied sites and approximately 43 people. He confirmed these numbers were accurate. Vargas told him that the park's overnight visitor log, a separate record maintained by the fee collection system, showed 127 registered overnight visitors at White River Campground on August 4th. Okafor was confused. 127 people would require at least 40 sites, assuming average occupancy. He had documented only 18. Vargas asked if Okafor might have missed occupied sites during his patrol. Okafor said it was unlikely. The campground loop was small, visibility was good, and he had walked every road. Occupied sites were marked by tents, vehicles, or camping equipment. Empty sites were obvious. He suggested that the overnight visitor log might contain an error, perhaps a data entry mistake, or a duplication. Vargas said she would investigate. Okafor heard nothing more for 2 weeks. On August 24th, Okafor was contacted by a different administrator, a man named Thomas Rousseau, who worked in the park's resource management division. Rousseau asked Okafor to meet with him at the Longmire office. When Okafor arrived, Rousseau was accompanied by another ranger, a woman named Jamal Desjardins, who had been stationed at the White River entrance gate on August 4th. Rousseau explained the discrepancy. The overnight visitor log showed 127 people at White River Campground on August 4th. Okafor's patrol report showed 18 occupied sites with approximately 43 people. Desjardins' entrance station report showed 71 vehicles entering through White River that day, of which 32 paid camping fees. These numbers don't match, Rousseau said. 127 registered campers, but only 18 occupied sites and 32 paid registrations. Where are the other 90-some people? Desjardins reviewed her entrance log. She confirmed that 32 parties had paid camping fees. Some were single individuals, others were families of 4 or 5. Her best estimate, based on party sizes noted during fee collection, was approximately 70 to 80 total campers. This was higher than Okafor's count, but nowhere near 127. I don't know where that number came from, Desjardins said. I logged every camping registration. I can account for the people who paid, but 127? That's not possible. Rousseau asked if there could have been campers who entered the park without paying or without registering. Okafor said it was theoretically possible, but unlikely. The White River entrance was staffed during daylight hours. After-hours entry was possible, but rangers patrolled regularly and would notice unauthorized camping. Additionally, the campground had been far from full. There was no reason for people to camp illegally when legitimate sites were available. Rousseau then asked a question that troubled Okafor. Did either of you see anything unusual on August 4th? Anything that stood out? Okafor thought for a moment. The day had been ordinary. Weather was poor. Visitor numbers were low. He had encountered no problems during his patrol, no noise complaints, no wildlife issues, no medical emergencies. Desjardins said the same. Her shift at the entrance station had been uneventful. Rousseau thanked them and said the matter would be reviewed further. Okafor and Desjardins left the meeting, unsure what was being investigated or why. The discrepancy seemed like a clerical error, a mistake in the overnight visitor log that would be corrected. In September 1989, Okafor was reassigned to the Carbon River District on the opposite side of the park. He was told the reassignment was part of routine staff rotation. Desjardins was moved to the Ohanapekosh entrance station in the park's southeast corner. Both reassignments were effective immediately. In October 1989, a journalist named Priya Bergstrom, writing for a regional outdoor magazine, contacted the Park Service to request visitor statistics for a story about summer camping trends. She asked for data on campground occupancy rates at various Mount Rainier campgrounds during July and August 1989. The Park Service provided summary data, but noted that detailed records for White River Campground during the first week of August were unavailable due to data processing issues. Bergstrom was puzzled by the response. She called the park's public affairs office and asked for clarification. A spokesperson told her that some records from that period had been transferred to archival storage and were not readily accessible. Bergstrom asked why. The spokesperson said that census methods were being revised and that some data from that period was being reviewed for accuracy before public release. Bergstrom pursued the story. She contacted Marcus Okafor, who declined to comment. She reached out to Jamal Desjardins, who said she was no longer authorized to discuss park records. Bergstrom filed a Freedom of Information Act request for the White River Campground records from August 1989. The request was acknowledged, but not fulfilled. 6 months later, she received a letter stating that the requested records could not be located in accessible archives. In 1991, a park volunteer named Yuki Tanaka was organizing old administrative files at the Longmire office. She found a folder labeled White River Campground, August 1989. Inside were copies of entrance logs, fee collection records, and patrol reports. Tanaka noticed the discrepancy between the overnight visitor count and the site occupancy. She mentioned it to her supervisor, a ranger named Dr. Amara Mbara. Mbara reviewed the documents. She saw the same numbers: 127 registered visitors, 18 occupied sites, 71 vehicles. She asked Tanaka where the folder had come from. Tanaka said it had been in a storage cabinet marked for disposal. Mbara took the folder and told Tanaka not to mention it to anyone. 2 days later, the folder was gone. Mbara told Tanaka that it had been sent to regional archives. Tanaka asked if she could get a copy for her own records, as she was compiling a history of the campground. Mbara said that would not be possible. In 1994, Marcus Okafor retired from the Park Service. In a conversation with a former colleague, he mentioned the August 1989 incident. "I've thought about it for years," he said. 127 people. Where were they? I walked that campground. I saw 18 sites. That's all there was. But someone, somewhere, logged 127 visitors. Either I missed something, or someone made up those numbers. I don't know which is worse. Jamal Desjardins left the Park Service in 1996 to work for the Forest Service. In a 2003 interview with a hiking blog, she was asked if she had any memorable experiences from her time at Mount Rainier. She paused before answering. "There was one thing that never made sense," she said. "A night in August, when the numbers didn't add up, I counted vehicles. I logged registrations, but the official record said something different. I asked about it. I was told not to worry. Then I was moved to a different station. I learned not to ask questions after that." In 2009, the Park Service digitized many of its historical records. Visitor logs, camping registrations, and entrance data from the 1980s and 90s were scanned and entered into databases. The White River Campground records from August 1989 were not included. A note in the digitization project summary stated, "Some records from this period are incomplete or damaged. and have been excluded from the digital archive. In 2015, a researcher named Thomas Vukovic was studying visitor patterns in national parks for a doctoral dissertation. He requested access to Mount Rainier's historical campground data. He received comprehensive records for most years and locations, but noticed that White River campground data for early August 1989 was missing. He asked park archivists about the gap. They told him that records from that period had been lost or misfiled during an office relocation in the 1990s. Vukovic contacted former rangers who had worked at Mount Rainier during that time. Most did not recall anything unusual. 1. A ranger who asked not to be named said, "There were things we didn't talk about, numbers that didn't match, reports that disappeared." You learn to do your job and not ask too many questions. The park was careful about its image. Anything that didn't fit the narrative got quietly set aside. White River Campground continues to operate each summer. Rangers patrol the sites each evening, counting occupied campsites and estimating visitor numbers. Entrance stations log vehicles and collect fees. The data is compiled and reported. The system is routine, efficient, and transparent. But in the archives, or perhaps in no archive at all, there exists a record of 127 people who were registered at White River Campground on August 4, 1989. 127 people who occupied 18 campsites. 127 people who arrived in 71 vehicles, 32 of which paid camping fees. 127 people who were counted by a system that could not explain where they were, who they were, or why the numbers refused to align with what the rangers saw that night when they walked the empty loop roads under the shadow of the mountain.